Sleep is one of the most universal experiences of human life, yet it remains one of the most mysterious. Every night, without fail, we drift away from the waking world into a state that is both familiar and strange. Our bodies grow heavy, our muscles soften, and the mind slowly releases its grip on conscious thought. We call it rest, but sleep is more than a pause in the day. It is a vast and intricate biological process that shapes nearly every aspect of who we are. It sustains the body, heals the mind, and carries us through a landscape of dreams that seem at once deeply personal and yet universal to all humanity. To begin exploring sleep, it helps to approach it gently, almost as if one were preparing for it. Imagine a quiet evening when the bustle of the day has fallen away. The air is calm, and the body feels the pull of rest. This natural cycle, repeated through countless lifetimes, reminds us that sleep is not simply a habit, but a profound rhythm of life itself. From the perspective of science, sleep is fascinating because it interrupts what we usually call awareness. The brain, which we often think of as the organ that keeps us awake and attentive, is just as active, sometimes even more so when we close our eyes and drift away. While the body lies still, the mind conducts its own nightly symphony, moving between different patterns of activity, consolidating memories, balancing chemistry, and producing vivid dreamscapes. For ancient cultures, this hidden realm seemed to be a portal to other worlds, a place where spirits, ancestors, and visions resided. For modern science, sleep is a frontier that reveals how fragile and how extraordinary the human brain can be. It is worth pausing to recognize how essential sleep island. Unlike food, which can be stored in the body as reserves of fat, or water, which can be rationed for a time, sleep offers no substitute. If it is missed, the body and mind begin to unravel in noticeable ways. Concentration fades, reaction times slow, and emotions become more fragile. In prolonged absence of rest, the body weakens, memory falters, and the very ability to perceive reality begins to distort. In this sense, sleep is not an option, but a requirement as fundamental as breathing. It reminds us that, despite all our waking ambitions, we are creatures bound by cycles of vulnerability and renewal. Throughout human history, the necessity of sleep has been both a curiosity and a source of meaning. Ancient Egyptians recorded dreams on papyrus, seeing them as messages from the gods. Greek philosophers speculated on the role of sleep as a way for the body to recover from the wear of the day. In medieval times, people described sleep as a little death, a nightly rehearsal for the great silence that eventually comes to all. Across these different interpretations, one idea endures. Sleep is not trivial, but essential, carrying mysteries that touch the deepest parts of human life. Today, scientific research continues this long tradition of inquiry, though the language has shifted from myths to neurons, from omens to brainwaves. Even so, the sense of wonder remains. The nightly descent into sleep follows a rhythm as regular as breathing. As evening draws on, the body produces signals that encourage rest. The eyes grow heavy, a calmness spreads through the body, and brain activity begins to shift into slower patterns. This transition from wakefulness to sleep is gradual. Much like the fading of light at dusk, one does not simply stop being awake and become asleep in an instant. Rather, the mind eases into it, moving through subtle stages of quieting and release. In the modern world, this process is often delayed or disrupted by artificial light, busy schedules, or emotional stress. Yet even with these obstacles, the pull of sleep is irresistible. Sooner or later, every living human being yields to it. Biologically, sleep appears in cycles, but experientially, it feels like a single journey. To the sleeper, The hours pass as if in a moment, yet the body moves through a carefully choreographed sequence of changes. Muscles relax, temperature drops slightly, and breathing slows. These physical shifts support the brain's work behind the scenes. Within the skull, networks of neurons begin to alternate between phases of slow synchronized activity and bursts of vivid, rapid firing. Each night, this dance repeats itself 4 or 5 times, as if the mind were rehearsing an ancient performance. The sleeper, meanwhile, drifts unaware, carried along by patterns laid down over millions of years of evolution. One of the great puzzles of sleep is why it should be necessary at all. From an evolutionary standpoint, lying still and unconscious for hours seems dangerous. A sleeping animal is vulnerable to predators, unable to flee, hunt, or defend itself. And yet, across the animal kingdom, sleep, or something very much like it, appears to be universal. Even creatures as small as fruit flies show cycles of rest that resemble sleep. Dolphins allow one half of their brain to sleep at a time, a strategy that keeps them breathing and alert to danger. Migrating birds snatch brief moments of rest while gliding. All of this suggests that whatever risks sleep brings, the benefits must outweigh them. Life has preserved it through every lineage, shaping it into countless forms. For humans, this benefit seems tied, not just to the body, but especially to the brain. The brain during sleep is a landscape of contrasts. In some phases, it grows quiet, waves of electrical activity spreading slowly and evenly, as if the mind were resting deeply. In others, it comes alive with bursts of energy, resembling wakefulness, but directed inward rather than outward. These are the moments when dreams bloom, when the brain creates images, voices, and stories entirely from within. To the dreamer, these visions feel real, yet they unfold in a space unbound by the limits of waking life. Some dreams are simple reflections of daily events, while others stretch into surreal territory, combining fragments of memory, emotion, and imagination. The experience is universal, yet always personal, a nightly reminder of the richness of the human mind. Despite centuries of speculation, dreams remain only partially understood. Are they messages from the unconscious, as Sigmund Freud once proposed? Are they the brain's attempt to organize memories, as modern neuroscientists suggest? Or are they simply random bursts of activity, woven into stories only after the fact? Science continues to search for answers, but in the gentle context of sleep, what matters is that dreams are part of the process. They arrive unbidden, carrying symbols, feelings, and insights, whether or not they hold objective meaning. For many people, dreams have been sources of art, inspiration, or guidance. For others, they are forgotten as quickly as they arrive, like smoke drifting into the morning air. As we begin this exploration of sleep and dreams, it is important to approach the subject with the same patience that sleep itself demands. There is no need to hurry or force understanding. Much like drifting into slumber, the knowledge comes gradually, unfolding layer by layer. Sleep is at once ordinary and extraordinary, familiar and mysterious. It is a biological necessity, a mental sanctuary, and a cultural symbol. By the time this journey through science is complete, one may not only understand sleep better, but also appreciate it more deeply as a quiet gift that sustains every life, every night, without fail. 2. The biological purpose of sleep. When considering the purpose of sleep, it is helpful to remember that nature does not waste energy on processes without reason. Every living creature, from the tiniest insect to the largest mammal, has developed patterns of rest that resemble what we call sleep. This alone suggests that the act of shutting down the senses and withdrawing into stillness must serve functions too important to abandon. Yet for centuries, humans puzzled over why sleep exists. Philosophers in ancient Greece thought of it as a temporary escape from the exhaustion of the day, a way for the soul to recover its strength. In more recent centuries, scientists have debated whether sleep is primarily for the body or for the brain, or for some subtle combination of both. What has emerged from decades of research is a picture of sleep as an essential biological necessity, one that influences every organ system, and perhaps most importantly, the mind itself. One way to think about the purpose of sleep is to view it as a process of restoration. During the waking hours, the body's systems are in constant use. Muscles contract and release, organs carry out their specialized duties, and the brain processes an endless stream of sensory input. By the time evening arrives, countless small imbalances have accumulated within cells. Nutrients have been consumed, proteins degraded, and waste products left behind. Sleep allows the body to shift gears, slowing overall activity while prioritizing repair. At the cellular level, energy stores are replenished, damaged molecules are replaced, and tissues are given the opportunity to heal. This is why even a single night of poor sleep can leave one feeling worn down, and why several nights without rest can make even the healthiest body feel fragile. Another theory highlights sleep as a mechanism of energy conservation. Unlike many animals, humans do not spend the night actively foraging or hunting. Instead, our bodies reduce energy expenditure by lowering temperature, slowing heart rate, and decreasing metabolic activity. From an evolutionary perspective, this would have been advantageous. By resting during the dark hours, when vision is limited and danger from predators might have been greater, early humans could conserve resources and reduce exposure. Even today, when artificial light extends activity far into the night, the body still follows this ancient rhythm, urging rest when darkness falls. The conservation of energy may not be the only purpose of sleep, but it offers one clue to why this cycle is so deeply embedded in life. The brain, however, seems to be where sleep's true importance lies. Although the body repairs itself during slumber, the brain engages in processes so intricate and essential that they cannot be postponed. Memory, for instance, depends on sleep. Throughout the day, the brain takes in vast amounts of information, from the trivial details of the environment to the more important knowledge of learning and experience. If all of this input remained scattered across different regions of the brain, it would quickly overwhelm the system. During sleep, especially during the deeper phases, the brain organizes and consolidates memories, transferring them from fragile short-term storage into more durable, long-term networks. This process explains why students who sleep after studying retain more than those who remain awake, and why important insights often arrive after a night's rest. Beyond memory, sleep contributes to emotional balance. The waking day exposes us to a wide spectrum of feelings: joy, frustration, worry, and hope. The brain must process these emotions, not just in the moment but also in the quiet hours afterward. Research suggests that during sleep, the brain revisits emotionally charged experiences, stripping them of their sharpest edge and weaving them into the broader fabric of memory. In this way, sleep provides a form of nightly therapy, allowing individuals to wake with a clearer perspective and greater resilience. Without it, emotions can become exaggerated, irritability increases, and stress becomes more difficult to manage. Thus, the purpose of sleep extends beyond simple rest into the realm of psychological well-being. There is also the matter of physical regulation. Many hormones, the body's chemical messengers, follow a circadian rhythm tied closely to sleep. Growth hormone, which stimulates repair of tissues and development in children, is secreted most strongly during deep sleep. Cortisol, The hormone associated with stress follows its own pattern, typically lowest at night and rising toward morning to prepare the body for wakefulness. The hormone melatonin, secreted by the pineal gland, increases in the evening as light diminishes, guiding the body into readiness for rest. These chemical patterns are not random, but are orchestrated to align with sleep cycles. Disruptions to them, such as those caused by shift work or long travel across time zones, can leave the body disoriented, underscoring how tightly sleep is woven into our internal biology. One of the most intriguing discoveries of recent years is the brain's method of cleansing itself during sleep. While the body is awake, brain cells produce waste products as part of their normal activity, including proteins linked to disorders like Alzheimer's disease. During sleep, particularly deep non-REM sleep, the spaces between brain cells expand slightly, allowing cerebrospinal fluid to wash through and clear away these byproducts. This system, called the glymphatic system, acts like a nighttime housekeeping service for the brain. Without it, waste could accumulate, leading to long-term problems. This nightly cleansing offers another reason why sleep is indispensable, and why the absence of it quickly affects mental sharpness. Although much of the purpose of sleep is biological, it also connects to the broader rhythm of life. Humans are diurnal creatures, active by day and resting by night. The cycle of light and darkness sets the tempo for countless internal processes. Within cells, tiny molecular clocks align activity to this rhythm, orchestrating when genes are expressed, when enzymes are active, and when energy is stored or released. Sleep is the outward expression of this inward timing, a daily resetting of the balance between activity and rest. To disregard it is to work against a system that has been refined over millions of years. Thus, the purpose of sleep is not only individual but also evolutionary, linking us to every generation of ancestors who lived by the rising and setting of the sunday. Even when sleep is disrupted, the body finds ways to demand repayment. After a night of deprivation, the next opportunity for sleep often brings longer and deeper rest, as if the body were insisting on making up for what was lost. This rebound effect illustrates how tightly regulated sleep island. It is not optional, not something that can be permanently reduced without cost. People may postpone it, shorten it, or try to ignore it, but the biological imperative remains. The consequences of chronic sleep loss, impaired immunity, weakened attention, increased risk of disease speak to the seriousness of its purpose. Perhaps what makes the purpose of sleep most remarkable is that it combines the physical with the mental, the tangible with the intangible. It restores muscles and tissues while also soothing emotions and consolidating thoughts. It regulates chemistry and cleanses the brain, while at the same time offering a space for dreams. In this dual role, sleep seems to embody the unity of body and mind, a nightly reminder that the two are not separate but deeply connected. To sleep is to allow the whole being to reset, to prepare for another cycle of life. In the end, the biological purpose of sleep may be many things at once. It conserves energy, it heals the body, it organizes the mind, it balances emotion, and it protects long-term health. To remove any of these functions would leave us incomplete, but together they form a process so essential that no living human can do without it. Sleep, in this sense, is not a luxury or an indulgence, but a requirement as ancient as life itself. Each night, when we lie down and surrender to it, we participate in a cycle that connects us to every creature that has ever closed its eyes and rested. It is nature's most universal gift, one that sustains us quietly, invisibly, and unfailingly. 3. The architecture of sleep. The night does not unfold as one long, unbroken stretch of slumber. Instead, it is composed of cycles, each one a careful sequence of stages that repeat again and again until morning arrives. This structure is sometimes called the architecture of sleep, and like a cathedral built of stone arches and hidden chambers, it has its own form, symmetry, and purpose. While from the outside it may appear that someone who is asleep is simply unconscious, inside the brain a delicate choreography is taking place. Waves of electrical activity rise and fall, muscles alternately relax and twitch, and the eyes dart behind closed lids as dreams begin. The architecture of sleep ensures that the body and mind receive the varied benefits of each stage, for no single part of sleep is sufficient on its own. A typical night of sleep for a healthy adult lasts about 7 to 9 hours, and within that span the body cycles through the stages of sleep 4 or 5 times. Each cycle lasts roughly 90 minutes, though the exact length can vary depending on age, health, and circumstances. Within each cycle, the sleeper moves through non-REM stages before entering REM sleep, then repeats the pattern again. As the night progresses, the balance between these stages shifts. Early in the night, deep non-REM sleep dominates, while toward morning, REM stages become longer and more frequent. This changing rhythm ensures that the body is restored physically first, and then the mind is given more time for dreams and memory processing later. Non-REM sleep itself is divided into 3 distinct stages, often labeled NUN, N2, and N3. The first stage, NUN, is the gentle threshold between wakefulness and sleep. It usually lasts only a few minutes, but during this time the body begins to drift into stillness. Muscles relax, breathing slows, and the brain produces slower alpha and theta waves. It is in this stage that one may experience hypnic jerks, those sudden twitches that sometimes jolt a person awake. Though light, this stage marks the beginning of true sleep, and it is easy to awaken someone from it. The second stage, N2, occupies the largest portion of the night. In this stage, the body relaxes further, and the brain's activity begins to show unique patterns called sleep spindles and K-complexes. Sleep spindles are bursts of rapid brain activity that seem to play a role in consolidating memories, while K-complexes are large, slow waves that may protect sleep by helping the brain remain undisturbed by minor external noises. During N2, body temperature drops, heart rate slows, and muscles loosen. This stage provides restfulness and stability, anchoring the night in a steady rhythm of recovery. The third stage, N3, is also known as slow wave sleep or deep sleep. It is the most restorative phase, when the brain produces slow delta waves and the body reaches its deepest state of rest. During this stage, tissues repair, growth hormone is released, and the immune system strengthens. It is also the stage most difficult to awaken from. If one is roused suddenly from deep sleep, confusion and grogginess often follow, a phenomenon known as sleep inertia. For children and adolescents, N3 sleep is especially important, supporting growth and development. For adults, it provides crucial repair and regulation. Without enough deep sleep, the body may feel physically weakened, even if total sleep time seems sufficient. After the non-REM stages, the sleeper enters rapid eye movement sleep, or REM. This stage is quite different from the others. Although the body is paralyzed to prevent acting out dreams, the brain becomes almost as active as it is during wakefulness. The eyes move rapidly beneath closed lids, breathing becomes irregular, and vivid dreams often unfold. REM sleep is believed to play a central role in learning, memory consolidation, and emotional processing. It is in this stage that the mind weaves together fragments of the day into narratives, sometimes coherent and sometimes surreal. The paralysis of the muscles, known as atonia, ensures that the body remains still, even while the dreamer might run, fly, or speak in their imagination. The alternation between non-REM and REM stages is vital. Each provides different benefits, and together they form a complete cycle of restoration. Without non-REM sleep, the body would lack the deep physical repair needed for health. Without REM sleep, the mind would be deprived of the integration and emotional regulation that keep thoughts and feelings balanced. The fact that the body insists on repeating this cycle night after night suggests that evolution has carefully shaped its necessity. As the night goes on, the proportion of each stage shifts. In the first half of the night, deep non-REM sleep is longer and more pronounced. The body takes this time to repair tissues, strengthen the immune system, and regulate energy. In the second half of the night, REM sleep grows longer, sometimes lasting up to an hour in a single stretch. This is why dreams are often more vivid and memorable in the early morning hours, and why waking from a dream is a common experience. This progression shows that the night is not uniform, but a gradual transition from physical restoration toward mental integration. Age also affects the architecture of sleep. Infants spend nearly half their sleeping hours in REM, reflecting the intense brain development that occurs in early life. As children grow, the proportion of deep, non-REM sleep increases, supporting growth and repair. In adulthood, the balance stabilizes, though the percentage of deep sleep gradually decreases with age. By the time one reaches old age, deep sleep is shorter and lighter, which may explain why many older adults wake more often during the night. Yet the cycles remain, a reminder that the architecture of sleep persists across the lifespan, even as its proportions change. The architecture of sleep is also sensitive to environment and lifestyle. Disrupted schedules, irregular light exposure, or stress can fragment cycles, reducing the quality of rest, even if the total hours seem adequate. For example, shift workers often struggle with irregular sleep because their bodies are forced to rest during the day, when light signals interfere with melatonin production. Similarly, the use of screens late at night can delay the onset of REM sleep by tricking the brain into thinking it is still daytime. These disturbances remind us that the architecture of sleep is delicate, requiring both time and proper conditions to unfold naturally. Despite its complexity, the architecture of sleep often goes unnoticed by the sleeper. We lie down, close our eyes, and surrender to the night, unaware of the intricate cycles happening within. Yet to understand these cycles is to appreciate sleep as more than simply rest. It is a sequence, a rhythm, a carefully balanced alternation between depths of silence and bursts of hidden activity. In its structure, sleep mirrors life itself, periods of calm, followed by moments of intensity, always in motion, always repeating. The beauty of the architecture of sleep lies in its subtle balance. No stage exists in isolation, and none can be removed without consequence. Like the stones of an arch, each supports the others, forming a whole that is greater than the sum of its parts. The body repairs, the brain consolidates, emotions soften, and dreams arise, all because the night is divided into its particular stages. To appreciate this architecture is to glimpse the quiet wisdom of the body, a wisdom refined through countless generations. Each time we sleep, we participate in this design, moving through cycles older than humanity itself, guided by rhythms that link us to the vast continuum of life. 4. Non-REM sleep. Deep restoration. Non-REM sleep, the portion of the night when the body enters its most profound stillness, is often described as the stage of deep restoration. It is here that the body, and especially the brain, carry out some of their most essential work. While waking life is filled with movement, activity, and constant processing of sensory information, non-REM sleep allows for something entirely different, a slowing down, a gentle withdrawal from the outer world, and a redirection of energy inward. Though the sleeper is unaware of it, every heartbeat, every breath, every shift in electrical activity within the brain is tuned toward the task of healing, renewing, and stabilizing the body's delicate systems. To understand the role of non-REM sleep is to recognize that much of what keeps us alive and healthy is accomplished not in the light of day, but in the quiet depths of the night. Non-REM sleep is divided into 3 stages: the light threshold of none, the stabilizing calm of N2, and the deep, slow wave sleep of N3. Each stage contributes something unique to restoration, and together they form the foundation on which the night's cycles are built. The earliest stage, none, is only a fleeting transition, lasting just a few minutes, as the body crosses from wakefulness into true sleep. During this brief moment, muscle tone begins to lessen, eye movements slow, and the brain produces slower theta waves. It is a fragile state, easily disrupted, but it marks the beginning of the night's journey. One might experience sudden twitches or drifting thoughts in this stage, as if the mind were hovering between 2 worlds. Though short, none prepares the body for the deeper restoration to come. The second stage, N2, is longer and more stable, accounting for nearly half of total sleep time. Here, the body settles more deeply into rest. The heartbeat slows, breathing becomes rhythmic, and body temperature falls slightly. Within the brain, curious bursts of activity appear, sleep spindles, and K-complexes patterns that neuroscientists believe are essential for memory consolidation and sensory protection. Sleep spindles are rapid bursts of electrical activity, thought to reinforce new connections between neurons. K-complexes, on the other hand, are large, slow waves that may act as a shield, preventing the brain from waking in response to small disturbances. Together, these patterns allow the mind to remain deeply asleep while still monitoring the environment for important signals, such as a baby's cry or a sudden loud noise. N2 is restorative not by complete withdrawal but by selective engagement, preserving the balance between safety and rest. The deepest stage, N3, is what most people mean when they speak of deep sleep. It is characterized by slow delta waves in the brain, large and synchronized rhythms that indicate widespread neural rest. In this stage, the sleeper is hardest to wake, and if disturbed, often feels groggy and disoriented. Yet, it is also the stage most critical for physical repair. Growth hormone is secreted during N3, stimulating the repair of tissues and the building of muscle and bone. The immune system strengthens its defenses, producing cytokines that help the body fight infection. Cells clear away metabolic waste, while others replicate to replace those lost or damaged during the day. For children and adolescents, N3 is especially vital, fueling the growth of the body and the development of the brain. For adults, it ensures that physical systems remain resilient, ready to meet the demands of another day. Non-REM sleep is also closely linked to the regulation of energy. During waking hours, the brain consumes a significant portion of the body's glucose, powering thought, movement, and perception. In non-REM sleep, however, glucose metabolism decreases, allowing energy stores to be replenished. This energy conservation not only reduces strain on the body, but also prepares the brain for the high levels of activity required during REM sleep and wakefulness. In this way, non-REM sleep serves as a kind of nightly accounting system, balancing expenditures and restoring reserves. Without it, the body quickly becomes depleted, leading to fatigue, irritability, and impaired performance. The importance of non-REM sleep becomes especially clear when it is disrupted. People who are deprived of slow-wave sleep may still spend many hours in bed, but they often awaken feeling unrefreshed. Their bodies may ache, their concentration may falter, and their immune systems may weaken. Studies have shown that even a single night without sufficient deep sleep can impair the ability of the body to regulate blood sugar, increase sensitivity to pain, and reduce the effectiveness of vaccines. Over time, chronic loss of non-REM sleep has been linked to serious health consequences, including cardiovascular disease, diabetes, and cognitive decline. Such findings highlight how much of health depends on processes that occur while we are unaware, resting quietly in the dark. Non-REM sleep also plays a subtle but important role in emotional regulation. While REM sleep is often associated with the vivid reliving of experiences in dreams, non-REM stages provide the groundwork by reducing activity in the stress systems of the brain. Cortisol, the hormone associated with stress, reaches its lowest point during deep non-REM sleep, allowing the body to experience a kind of nightly reprieve. This lowering of stress hormones not only protects physical health, but also allows the mind to approach the next day with greater calm. In this sense, non-REM sleep is like the silent backdrop against which emotional processing can occur, soothing the nervous system and restoring balance. Children demonstrate another fascinating aspect of non-REM sleep. In the early years of life, they experience far more deep sleep than adults, sometimes spending more than half the night in slow-wave stages. This abundance of deep sleep reflects the immense work of growth and development taking place in their bodies. As the brain builds new connections at a rapid pace, and as the body lengthens bones and strengthens muscles, deep non-REM sleep provides the necessary foundation. Even behaviors such as sleepwalking and night terrors, which occur most often in children, are linked to this stage. They reveal just how deeply the brain is immersed in the cycles of activity and rest, sometimes allowing fragments of movement to escape even while consciousness remains absent. Across the lifespan, non-REM sleep changes in both quantity and quality. Infants and young children experience long stretches of deep sleep, while adults experience shorter and lighter episodes. By old age, the amount of slow-wave sleep may diminish significantly, leading to more awakenings during the night and less overall restoration. Yet even in later life, the body still seeks out non-REM sleep, adjusting cycles to preserve at least some measure of deep rest. These changes remind us that the architecture of sleep is dynamic, adapting to the needs of the body at different stages of life. Although non-REM sleep may not carry the drama of dreams, its quiet work is no less profound. It is the stage where the body heals, where the immune system strengthens, where energy is restored, and where the foundation for learning and memory is laid. Without it, life quickly becomes fragile, both physically and mentally. With it, the body emerges each morning, renewed, carrying forward the strength to live, move, and think. Non-REM sleep is the nightly labor of the body in silence, a reminder that the deepest forms of restoration often take place beyond awareness, in the gentle embrace of stillness. In reflecting on non-REM sleep, one sees a picture of life itself. There is a rhythm of exertion and rest, of activity and recovery. Just as the earth itself alternates between day and night, so too does the body alternate between waking and non-REM slumber. The night is not wasted time but an essential process of renewal, a gift repeated with each cycle of life. To sleep deeply is to allow the body and mind to return to their natural equilibrium, to prepare for the challenges and possibilities of another day. In the silence of non-REM sleep, the body remembers how to heal, and the mind remembers how to be whole. 5. REM sleep, the theater of dreams. When the night deepens and the sleeper moves beyond the quiet depths of non-REM rest, the mind enters a remarkable stage of activity known as rapid eye movement sleep, or REM. This stage is unlike any other. While the body lies still, almost entirely paralyzed to prevent movement, the brain becomes almost as active as it is during wakefulness. The eyes dart back and forth beneath closed lids. Breathing grows irregular. Heart rate quickens. And the mind begins to conjure vivid and immersive experiences that we call dreams. If non-REM sleep is the workshop of repair and renewal, REM sleep is the theater of imagination, a nightly performance where memory, emotion, and creativity mingle in ways that often surprise us upon waking. The discovery of REM sleep in the 1950s transformed the scientific understanding of sleep. Before then, many assumed that slumber was a passive state, simply a withdrawal from the world. But when researchers noticed the strange eye movements and bursts of brain activity in sleeping volunteers, they realized that something extraordinary was happening. Electroencephalography, which measures the brain's electrical activity, revealed that REM sleep resembles wakefulness more than deep rest. In fact, the brain's patterns of activity during this stage are so lively that REM is sometimes called paradoxical sleep, a state where the mind is highly active while the body is almost entirely immobile. This paradox is one of the reasons dreams feel so vivid, for the brain is functioning in a manner not unlike waking life, yet detached from external input. During REM sleep, the brainstem sends signals that shut down motor neurons, inducing a state of atonia or paralysis. This prevents the dreamer from acting out the often dramatic events of their dreams. It is a protective mechanism, one that allows the mind to wander freely without risk to the body. At the same time, the visual and emotional centers of the brain, including the amygdala and occipital cortex, light up with activity. This explains why dreams often carry such intense imagery and emotional weight. Meanwhile, the prefrontal cortex, responsible for logic and rational control, is less active, giving dreams their often illogical and surreal quality. In dreams, time may bend, impossible events may unfold, and the ordinary laws of reality may dissolve. Yet within the dream, they feel strangely natural. The content of dreams can range from the mundane to the fantastical. Sometimes one dreams of walking through familiar streets or speaking with acquaintances from daily life. Other times, the dream may transport the sleeper to impossible landscapes, soaring above mountains, breathing underwater, or encountering figures long forgotten. Dreams often weave together fragments of recent experiences with distant memories, creating narratives that defy easy explanation. Scientists believe that this blending reflects the brain's attempt to process, organize, and integrate information gathered during waking hours. In this sense, dreams are not meaningless illusions but a byproduct of the brain's ongoing work to make sense of life. One of the most significant roles of REM sleep lies in memory consolidation. While non-REM sleep stabilizes and strengthens certain types of factual and procedural memories, REM sleep appears to integrate emotional experiences and creative associations. This may be why people often wake with fresh insights after dreaming, or why unresolved emotions feel softened after a night's rest. The brain during REM is thought to replay emotional experiences, stripping them of their sharpest edges and weaving them into a broader context. This helps to regulate mood and maintain psychological balance. Without adequate REM sleep, emotions may become raw and unprocessed, leading to irritability, heightened stress, and even symptoms of depression. Dreams also provide a unique space for creativity. Many artists, scientists, and writers have reported that their ideas came to them in dreams. The surreal associations of REM sleep allow the brain to connect concepts that might never meet in the structured logic of waking thought. A melody might be heard, an image seen, or a problem solved in this nocturnal theater. While not every dream holds such revelations, the potential for creative insight is one of the gifts of REM sleep, reminding us that imagination does not rest when we close our eyes, but continues its work in hidden ways. The balance of REM sleep changes across the night. In the early hours, REM episodes are short, lasting only a few minutes. As the night progresses, they lengthen, sometimes reaching nearly an hour in the final cycle before waking. This explains why dreams often feel longest or most memorable in the morning. The shifting balance also shows how sleep is not uniform but dynamic, with the body first prioritizing deep physical repair through non-REM stages before devoting more time to the emotional and cognitive processes of REM. It is a rhythm carefully orchestrated by the body, ensuring that both the physical and mental needs of the individual are met each night. The importance of REM sleep is underscored by what happens when it is deprived. People who are prevented from entering REM often experience mood disturbances, difficulty concentrating, and heightened anxiety. Over longer periods, REM deprivation can impair learning, reduce creativity, and disrupt emotional regulation. When finally allowed to sleep normally, the body often enters REM more quickly and spends longer in it, a phenomenon known as REM rebound. This demonstrates how strongly the body seeks out this stage, treating it not as a luxury but as a necessity. The universality of REM sleep across the animal kingdom adds to its significance. Mammals and birds experience REM, with their eyes moving beneath closed lids, and their brains becoming active in ways similar to humans. Even some reptiles and fish show patterns that may resemble REM-like states. This widespread presence suggests that REM sleep serves fundamental biological functions, conserved through evolution because of its importance to survival. Though we cannot know what a cat or bird dreams about, their twitching whiskers, fluttering wings, and rapid eye movements hint at a hidden world of imagery not so different from our own. While dreams are deeply personal, they also reveal something universal about the human condition. Across cultures and throughout history, people have sought meaning in dreams, seeing them as messages from gods, ancestors, or the unconscious mind. Ancient Egyptians recorded dreams on papyrus, while Greek philosophers debated their significance. In modern times, psychologists such as Sigmund Freud and Carl Jung explored dreams as windows into the unconscious, filled with symbols and hidden desires. Today, neuroscience offers a more biological view, suggesting that dreams arise from the brain's nightly work of memory integration and emotional processing. Yet the fascination endures, for dreams remain among the most mysterious experiences of human life, hovering at the boundary between the real and the imagined. The theater of REM sleep reminds us that rest is not the absence of activity, but a transformation of it. In the stillness of the body, the mind becomes a stage, conjuring vivid experiences that allow us to process the day, regulate emotions, and explore the landscapes of imagination. Every night, as the cycles repeat, we return to this theater without effort or intention, carried there by rhythms older than memory. To understand REM sleep is to see sleep itself not as a single state, but as a tapestry woven of many threads, some devoted to the body, others to the mind. In the end, REM sleep is one of nature's most extraordinary gifts. It allows us to dream, to feel, to create, and to heal in ways that waking life alone cannot provide. The theater of dreams, though fleeting and often forgotten, is no less real for its impermanence. It is the nightly reminder that within the silence of sleep lies a world alive with motion, emotion, and imagination. Each morning, we awaken, having traveled through that hidden landscape, carrying with us traces of its lessons, its mysteries, and its quiet restoration. 6. Dreams through human history. Dreams have accompanied humanity since the earliest stirrings of consciousness. Long before the language of neurons and brainwaves, people looked upon the strange images of the night as messages from beyond. They seemed too vivid, too strange, and too powerful to belong only to the sleeper. In every corner of the world, across centuries and cultures, dreams were woven into the fabric of belief, ritual, and philosophy. To trace the history of dreams is to glimpse how humans have sought meaning in the unknown, interpreting the theater of sleep as a bridge between the earthly and the divine, between the ordinary and the extraordinary. In the ancient world, dreams were often regarded as divine communications. Among the Sumerians of Mesopotamia, who left behind some of the earliest written records, dreams were described on clay tablets dating back over 4,000 years. These people believed that gods, spirits, or ancestors spoke through dreams, offering guidance or warnings. Dream interpreters, known as seers, occupied respected positions, consulted by rulers who wished to understand the hidden will of the heavens. A dream could be seen as a prophecy, shaping decisions about war, agriculture, or governance. To ignore it was to risk offending the powers believed to dwell beyond the waking world. The Egyptians, too, held dreams in high regard. They created dream books, collections of symbols and their supposed meanings, which priests and wise men used to interpret the visions of those who sought guidance. If one dreamt of rivers or floods, it might mean abundance. If of fire, it could be a warning. Temples sometimes doubled as dream sanctuaries, where individuals would sleep in the hope of receiving a healing vision from the gods. For them, dreams were not random or trivial but sacred, threads of connection between humans and the divine order of the cosmos. In the classical world of Greece, dreams became a subject of both spirituality and philosophy. Homer's epics describe dreams as messengers, sometimes sent by Zeus himself. In the Iliad, a false dream misleads Agamemnon, while in the Odyssey, Penelope distinguishes between true dreams, sent by gods, and false dreams, mere illusions. Greek philosophers approached dreams with curiosity and analysis. Aristotle, in particular, considered them natural phenomena arising from the workings of the body and mind. For him, dreams reflected the impressions left upon the senses, reassembled in new ways during sleep. Plato, meanwhile, suggested that dreams revealed the hidden desires of the soul, a theme that would echo centuries later in modern psychology. The Romans inherited both the spiritual and the rational approaches to dreams. Cicero wrote of them with skepticism, questioning their predictive power, while others embraced them as omens guiding the state. The practice of dream interpretation was so widespread that even emperors consulted interpreters before making important decisions. The Roman writer Artemidorus compiled a vast manual on dream interpretation, detailing hundreds of symbols and their supposed meanings. His work was studied for centuries, shaping the way people approached dreams well into the Middle Ages. In the traditions of the Hebrew Bible, dreams held a special role as vehicles of divine revelation. The story of Joseph interpreting Pharaoh's dreams, 7 fat cows devoured by 7 lean ones, remains one of the most well-known examples of symbolic dreams shaping real-world events. Prophets and patriarchs alike reported dreams in which God's will was revealed, reinforcing the belief that dreams could guide entire communities. In this way, dreams were seen not as personal fancies but as messages of cosmic significance. Across Asia, dreams took on equally profound roles. In ancient China, the philosopher Zhuangzi famously dreamt he was a butterfly, only to awaken and wonder if he was a man who had dreamt of being a butterfly, or a butterfly dreaming of being a man. This parable reflected the deep philosophical questions. Dreams inspired questions about the nature of reality and the boundaries of identity. Chinese traditions often regarded dreams as journeys of the spirit, temporary excursions of the soul into other realms. Similarly, in India, dreams were linked to the spiritual dimensions of existence, described in texts such as the Upanishads as states of consciousness, alongside waking and deep sleep. For Hindus and Buddhists alike, dreams were not only mysterious but also instructive, offering glimpses of the illusory nature of the world. Indigenous cultures around the world have also woven dreams into their spiritual lives. Among many Native American tribes, dreams are seen as sacred messages and sources of power. The Lakota, for example, regarded dreams as pathways to visions, guiding individuals toward their life's purpose or connecting them with spiritual guardians. Dream catchers, woven to filter out harmful dreams while allowing beneficial ones to pass, reflect the enduring respect for the messages of sleep. In Australia, Aboriginal cultures hold the concept of the dream time, a sacred narrative in which ancestral beings created the world. Though distinct from nightly dreams, this cosmology reflects the deep connection between dream states and the origins of meaning. As the Middle Ages unfolded in Europe, dreams continued to hold sway, though their interpretations shifted with the rise of Christianity. Church authorities sometimes regarded them with suspicion, associating them with temptation or demonic influence, yet they could also be seen as divine visions, as in the case of saints who dreamt of angelic encounters. Monastic writers debated whether dreams came from God, from the devil, or from the restless workings of the body. In this tension, dreams remained powerful but ambiguous, capable of both guiding and misleading. The Renaissance brought a renewed interest in classical ideas, and with it a revival of Aristotelian and Platonic approaches to dreams. Scholars began to study them as natural phenomena rather than solely as divine interventions. Physicians linked dreams to humors and bodily imbalances, while philosophers speculated on their connection to imagination and memory. This more rational view did not erase the spiritual dimension, but it laid the groundwork for modern inquiry into the nature of dreams. By the 19th century, dreams had become a central focus of emerging psychology. Sigmund Freud argued that they revealed the unconscious desires and conflicts of the individual, disguised through symbols and narratives. For Freud, dreams were the royal road to the unconscious, offering insights into hidden parts of the psyche. Carl Jung expanded upon this view, seeing dreams as expressions of archetypes and the collective unconscious, symbols shared across humanity. These perspectives shaped the modern understanding of dreams, shifting the focus from divine messages to the inner workings of the human mind. Even today, dreams continue to inspire fascination. Neuroscience has revealed much about the mechanisms of REM sleep and brain activity, yet the meaning of dreams remains elusive. Some researchers view them as the brain's attempt to integrate memory and emotion, while others suggest they are byproducts of neural activity without inherent meaning. Yet for dreamers themselves, the experience often feels significant. Dreams can comfort, disturb, inspire, or puzzle, leaving behind impressions that linger long after waking. The history of dreams reveals a tapestry of interpretations: divine message, philosophical riddle, medical symptom, psychological key. Across time, one constant remains: the sense that dreams matter. They invite reflection, spark creativity, and connect individuals to something beyond ordinary perception. Whether regarded as messages from gods, fragments of the unconscious, or patterns of brain activity, dreams remind us of the mystery that lies within the simple act of sleep. Each night, when we close our eyes, we step into a tradition as old as humanity itself, joining countless generations who have sought meaning in the shadows of the mind. 7. The modern science of dreaming. In the long history of human fascination with dreams, few developments have reshaped our understanding as profoundly as the rise of modern science. Where earlier ages saw dreams as divine messages, omens, or glimpses into hidden realms of the spirit, the modern era has approached them with the tools of observation, experiment, and measurement. This does not mean that the mystery of dreams has vanished. Instead, it has taken on a new form, one that balances the subjective strangeness of the dream experience with the objective study of the brain. Modern science has revealed that dreams are closely tied to sleep architecture, brain activity, memory, and emotion. Yet even with all this knowledge, the meaning and purpose of dreams continue to inspire debate. The modern study of dreaming is rooted in the discovery of REM sleep in the mid-20th century. When researchers noticed the rapid eye movements and vivid brain activity that accompany this stage, they realized that the most intense and memorable dreams occur during these episodes. Electroencephalography revealed patterns of activity that looked remarkably similar to wakefulness, leading to the description of REM sleep as paradoxical. The realization that the brain does not rest quietly during the night, but instead creates an active inner world, opened the door to a new era of dream science. For the first time, researchers could link subjective dream reports with objective physiological states, allowing the study of dreams to move from speculation into measurable reality. One of the earliest and most influential scientific theories of dreaming was the activation synthesis hypothesis, proposed by researchers Alan Hobson and Robert McCarley in 1977. According to this model, dreams arise from random bursts of neural activity in the brainstem. These signals, reaching higher cortical areas, are synthesized into coherent narratives by the brain's interpretive systems. In other words, the brain takes chaotic internal signals and weaves them into stories, much as it interprets external stimuli during waking life. This theory suggested that dreams were not deliberate messages but byproducts of the brain's activity during REM sleep. While the hypothesis downplayed symbolic meaning, it highlighted the remarkable capacity of the brain to create narrative from disorder. Since then, the science of dreaming has expanded into many directions. One line of research emphasizes the role of dreams in memory consolidation. Studies have shown that people who are allowed to enter REM sleep after learning new information often perform better on memory tests than those who are deprived of it. The content of dreams frequently reflects recent experiences, incorporating fragments of daily life into strange and sometimes distorted scenarios. This blending of memory fragments suggests that dreams may help integrate new knowledge with existing mental frameworks, reinforcing important connections and discarding irrelevant details. In this sense, dreaming is not random at all, but part of the brain's nightly effort to make sense of experience. Another area of research focuses on the relationship between dreaming and emotion. The amygdala, a region of the brain central to emotional processing, is highly active during REM sleep. Dreams often carry strong emotional tones: fear, joy, sadness, or wonder, reflecting the amygdala's influence. Some scientists propose that dreams provide a safe space for the brain to process difficult emotions, replaying stressful or traumatic events in a less threatening context. This could explain why people who have undergone intense experiences often dream about them repeatedly, gradually softening their emotional impact. The theory suggests that dreaming functions as a form of overnight therapy, allowing the brain to regulate mood and maintain psychological balance. Neuroimaging studies have also revealed much about the brain's activity during dreaming. The visual cortex, responsible for processing images, is highly active, accounting for the vivid scenes and shifting landscapes of dreams. The prefrontal cortex, associated with logic and decision-making, is less active, which helps explain why dreams often lack coherence and follow strange, illogical plots. The hippocampus, critical for memory, works in tandem with other regions to replay and reorganize information. Altogether, these patterns reveal that dreaming is not confined to a single brain area but involves a complex network of regions working together. Despite this progress, the question of dream meaning remains unsettled. While the activation synthesis model suggests that dreams are simply byproducts of brain activity, other theories emphasize their adaptive value. The threat simulation theory, for instance, proposes that dreams evolved as a way to rehearse responses to danger. By simulating threatening scenarios in a safe environment, the dreamer could strengthen survival instincts. Other theories argue that dreams support creativity, by allowing the brain to explore unusual combinations of ideas. These perspectives remind us that dreaming may serve multiple purposes, from emotional regulation to imaginative problem solving. Modern research has also explored the phenomenon of lucid dreaming, in which the dreamer becomes aware that they are dreaming and may even exert some control over the dream. Lucid dreaming has been studied using brain scans and eye movement signals, confirming that it is a real and measurable state. In lucid dreams, parts of the prefrontal cortex show increased activity, suggesting a partial return of self-awareness and executive control. For scientists, lucid dreaming offers a unique window into consciousness itself, blurring the line between the dreaming and waking states. For dreamers, it offers the chance to explore the dream world intentionally. Though even in lucidity, the dream retains its surreal, shifting quality. The science of dreaming has also begun to investigate the relationship between dreams and mental health. Disturbances in dreaming are associated with conditions such as post-traumatic stress disorder, where nightmares replay traumatic events with distressing intensity. Conversely, some therapies encourage patients to re-script their nightmares, altering their outcomes within the dream to reduce fear and restore a sense of control. Depression and anxiety, too, often affect dreaming, leading to changes in frequency, intensity, and tone. These findings suggest that dreams are not merely reflections of the mind but active participants in mental well-being. Technological advances have brought new possibilities to dream research. Experiments with brain-computer interfaces have attempted to decode dream content by analyzing patterns of neural activity. While still in early stages, these efforts hint at the possibility of reconstructing dream imagery, bringing the private theater of the mind into observable form. Other studies have used external cues, such as sounds or odors, to influence dream content, demonstrating that the boundary between waking and dreaming is more permeable than once believed. These approaches may one day allow more precise exploration of how dreams are formed and how they can be guided. Yet for all the progress of neuroscience, dreams retain their mystery. They are at once products of biology and deeply personal experiences. No scan or theory can fully capture the feeling of flying through impossible skies, or the sudden recognition of a loved one long gone. Dreams resist reduction to pure mechanism, because they are lived from within, carrying meanings and emotions that only the dreamer can truly grasp. Science can illuminate their origins, their functions, and their patterns, but the intimate experience of dreaming belongs to the realm of subjectivity. In the modern view, then, dreams can be seen as both biological processes and human experiences. They are the result of neural activity, memory consolidation, and emotional regulation. Yet they are also stories, images, and feelings that shape our inner lives. The science of dreaming does not diminish their wonder. Instead, it deepens it, showing that the strangeness of dreams arises from the very complexity of the brain. Each night, as REM sleep returns, the brain builds its own narratives, weaving together memory, emotion, and imagination. Whether we remember them or not, dreams accompany us always. Silent companions in the theater of sleep. 8. Memory and learning. During sleep, throughout the day, the human brain is flooded with information. Every conversation, every movement, every sight and sound leaves its mark, however faint, on the nervous system. Some impressions are trivial, like the color of a passing car or the pattern of footsteps on the sidewalk. Others are essential, such as a new skill being practiced, an important fact to remember, or an emotional experience that stirs the heart. If all of this material simply remained scattered and unorganized, the brain would soon be overwhelmed. What allows human beings to learn, to remember, and to build upon experience is the quiet work that happens during the night. Sleep, especially its deeper phases, is not a pause from learning but an essential partner to it. Each night, the brain sorts, strengthens, and refines the memories gathered during the day, ensuring that what matters most is preserved and what is unnecessary is allowed to fade. Memory is not a single process but a collection of different systems. There is short-term memory, which holds small amounts of information for brief periods, like a phone number just long enough to dial it. There is working memory, which manipulates information actively, such as when solving a problem in the mind. Then there is long-term memory, where experiences are stored more permanently, forming the foundation of knowledge, skills, and personal history. Within long-term memory itself, there are distinctions: declarative memory, which encompasses facts and events, and procedural memory, which stores skills and habits. Each of these forms of memory interacts with sleep in different ways, revealing the complexity of the brain's nightly labor. During non-REM sleep, particularly in the slow wave stages, declarative memory receives special attention. Studies using brain imaging and electrical recording have shown that the hippocampus, a seahorse-shaped structure critical for memory, replays patterns of activity experienced during the day. These replays are like echoes of waking life, as if the brain were rehearsing important experiences to strengthen their imprint. Neurons that fired together during learning are reactivated, reinforcing the connections between them. This process, known as consolidation, helps transfer memories from the fragile temporary storage of the hippocampus into the more durable networks of the cortex. Without this transfer, memories might remain unstable, easily forgotten. With it, they become part of the broader fabric of knowledge, integrated with older experiences and available for later recall. Procedural memory, by contrast, seems to depend more heavily on REM sleep. When people learn a new motor skill, such as playing a sequence on a piano, practicing a tennis swing, or mastering a new dance performance, often improves after a night of sleep, even without additional practice. The improvement is not simply the result of rest but of active processing during REM. The brain rehearses patterns of movement, strengthens pathways in motor regions, and refines coordination. This is why athletes, musicians, and learners of all kinds often find that their abilities advance overnight. The brain, in essence, continues training while the body rests. Emotional memory also benefits from sleep. Experiences charged with strong feelings, whether joy, fear, or sadness, are given special treatment by the sleeping brain. The amygdala, a structure central to emotion, remains active during REM sleep, allowing the brain to revisit emotional experiences. Yet the context is altered. Stress hormones such as norepinephrine are reduced, creating a safer environment in which to reprocess difficult memories. This mechanism may explain why emotional events gradually lose their sting over time, softened by repeated nights of dreaming. In this way, sleep not only preserves emotional memories, but also reshapes them, allowing individuals to carry forward the lessons without being overwhelmed by the intensity. The role of sleep in learning extends beyond memory consolidation. Sleep also fosters insight and problem-solving. Experiments have shown that individuals confronted with a challenging puzzle or logical task often find the solution more easily after a night of sleep. The brain during REM appears to explore associations more freely, connecting ideas that remain separate in waking life. This openness to unusual combinations can lead to creative breakthroughs, the kind that arrive suddenly in a dream or in the quiet clarity of morning. Famous examples abound: scientific discoveries, artistic inspirations, and inventive solutions, reportedly born in dreams or upon awakening. While not every problem is solved in this way, the evidence suggests that sleep provides fertile ground for creative thought. The interaction between sleep and learning is also visible in development. Infants and young children spend a significant portion of their sleep in REM, a stage believed to support the rapid growth of the brain. During this period of life, when new skills are being acquired, daily walking, talking, recognizing, and understanding, the abundance of REM provides the necessary scaffolding. As children grow, the balance of sleep stages shifts, but the principle remains. Learning by day requires sleep by night to become lasting knowledge. For adults, the need persists, though the cycles become more refined and less abundant. Even in old age, sleep continues to support memory, though changes in sleep architecture can make this process less efficient, contributing to the forgetfulness often associated with aging. When sleep is disrupted, the effects on memory and learning are immediate. Students who study late into the night but sacrifice sleep often find that their recall suffers. Workers deprived of rest may struggle to concentrate, their learning impaired despite repeated effort. Chronic sleep deprivation leads to cumulative deficits, with attention, memory, and reasoning all weakened. The hippocampus, deprived of its nightly chance to replay and consolidate, cannot embed new experiences effectively. In this way, insufficient sleep undermines the very foundation of learning. Rest is not wasted time but an essential investment in the ability to think, remember, and create. Modern neuroscience has provided remarkable glimpses into how these processes unfold. Techniques such as functional magnetic resonance imaging have shown how the hippocampus and cortex exchange information during sleep, while electroencephalography reveals the waves and rhythms that accompany memory consolidation. In some experiments, researchers have even introduced subtle cues, such as sounds or odors associated with learning during sleep, finding that these cues can strengthen memory. Such findings suggest that the sleeping brain is not sealed off but remains receptive to certain forms of influence, opening intriguing possibilities for enhancing learning. Despite these insights, much remains mysterious. Why some dreams incorporate fragments of memory while others do not. Why certain experiences are consolidated while others fade. And why sleep deprivation impairs one type of memory more than another. All of these questions continue to inspire research. What is clear is that the relationship between sleep and memory is not simple but multifaceted, involving distinct stages, regions, and processes that interact in subtle ways. The nightly labor of memory and learning may be silent, but its impact is profound. Every word remembered, every skill improved, every lesson carried forward depends in part on the work of sleep. Without it, life would be a series of disconnected moments, soon forgotten. With it, experiences accumulate, knowledge deepens, and the self extends across time. Sleep transforms fleeting impressions into lasting understanding, shaping not only what we know but who we are. Each night, as the cycles repeat, the brain continues this work, ensuring that waking life builds upon itself, rather than dissolving into fragments. To learn, then, is to engage not only with the world of daylight but also with the world of sleep. Memory and learning are not confined to conscious effort but rely on unconscious processes that unfold in silence. The brain, in its wisdom, uses the night to complete the work of the day. In doing so, it allows each human being to carry forward a growing store of knowledge, emotion, and skill, building a life that is both continuous and evolving. Sleep, far from being a pause in learning, is its greatest ally, the unseen partner that turns experience into memory and memory into wisdom. 9. The brain's nightly housekeeping. Every organ in the human body requires maintenance, and the brain is no exception. During waking hours, it is flooded with electrical activity, processing sights, sounds, thoughts, decisions, and countless automatic functions that sustain life. This constant work produces byproducts, much like a busy city leaves behind waste at the end of a long day. For decades, scientists wondered how the brain managed to cleanse itself, for unlike other organs, it is shielded by the blood-brain barrier, a protective wall that limits what can enter and leave its tissues. The answer, discovered only in recent years, is that the brain performs its own nightly housekeeping, a process that becomes most active during sleep. In this hidden labor, the brain clears away toxins, reorganizes connections, and restores balance, preparing itself for another day of thought and experience. The brain's cleansing system is known as the glymphatic system, a network of channels that allow cerebrospinal fluid to wash through brain tissue. By day, this system operates at a minimal level. But at night, particularly during deep non-REM sleep, it becomes highly active. Fluid flows along specialized pathways, sweeping away proteins and other metabolic waste that accumulate between cells. Among the substances cleared is beta amyloid, a protein that, when left unchecked, can clump into plaques associated with Alzheimer's disease. Another is tau, a protein that forms tangles inside neurons and contributes to neurodegeneration. The nightly removal of such substances is not just helpful but vital, for their buildup over time may lead to long-term cognitive decline. Sleep, therefore, is not simply restorative, it is protective, guarding the brain against the slow accumulation of damage. The discovery of the glymphatic system was a turning point in neuroscience. For years, it was assumed that the brain lacked a lymphatic network, like the rest of the body, leaving scientists puzzled about how it managed waste removal. The realization that sleep opens channels for fluid exchange provided an elegant solution. During deep sleep, brain cells shrink slightly, creating more space between them. This expanded space allows cerebrospinal fluid to flow more freely, washing through tissue in rhythmic pulses synchronized with the heartbeat. The result is a nightly cleansing bath, renewing the brain in ways impossible during wakefulness. This process highlights why deep sleep feels so refreshing, because at the cellular level, the brain has literally been washed clean. Housekeeping in the brain, however, goes beyond physical cleansing. Another crucial task of sleep is the pruning and strengthening of synaptic connections. Every day, as we experience the world, neurons form new connections to encode memories and learn new skills. These connections are established by the growth of tiny protrusions called dendritic spines, which link one neuron to another. Left unchecked, however, the accumulation of connections could overwhelm the brain, using excessive energy and reducing efficiency. Sleep provides the opportunity for synaptic homeostasis, a process in which unnecessary or redundant connections are trimmed while important ones are reinforced. This pruning ensures that the brain remains flexible and efficient, capable of learning new information without becoming overloaded. This synaptic housekeeping can be compared to the editing of a manuscript. During the day, countless sentences are written, some clear, others repetitive, some essential, others irrelevant. At night, during sleep, the brain acts as its own editor, deleting what is unnecessary, refining what is useful, and ensuring that the story of memory and knowledge remains coherent. Without this editing, learning would become confused, and memory would grow cluttered. With it, the brain emerges each morning, better organized, streamlined for new challenges. The nightly housekeeping also involves balancing the chemistry of the brain. Neurotransmitters, the molecules that allow neurons to communicate, are produced and released constantly during wakefulness. Dopamine fuels motivation and attention, serotonin supports mood, and glutamate drives excitatory signals across synapses. Over time, these chemicals become depleted or imbalanced. Sleep allows their levels to reset, restoring sensitivity to signals and maintaining the harmony of brain circuits. Hormonal regulation also plays a role. with melatonin guiding sleep onset, growth hormone supporting repair, and cortisol following its daily rhythm to prepare the body for waking. This chemical rebalancing ensures that the brain does not become overstimulated or exhausted, preserving both clarity of thought and stability of mood. The importance of the brain's housekeeping becomes evident when sleep is disrupted. Even a single night of deprivation allows waste products to accumulate, leaving the brain sluggish and foggy. Concentration falters, reaction times slow, and memory weakens. With chronic sleep loss, the glymphatic system cannot perform its cleansing duties effectively, and harmful proteins begin to accumulate. Over years, this may increase the risk of neurodegenerative disease. Similarly, without proper synaptic pruning, learning becomes less efficient, and the brain struggles to distinguish important information from noise. These consequences reveal that sleep is not merely restful, it is essential for maintaining the physical and functional health of the brain. The metaphor of housekeeping extends beyond the biological processes to the subjective experience of sleep. Many people notice that after a good night's rest, problems that seemed insurmountable the day before feel more manageable. Emotions that were raw soften, and thoughts that were tangled appear more orderly. This mental clarity reflects the brain's nightly reorganization. As memories and emotions are sorted and integrated, the mind itself feels cleaned, as if a cluttered room had been tidied in the dark. This effect is so consistent that it has entered everyday language. To sleep on it is to trust that rest will provide perspective and resolution. Different stages of sleep appear to contribute uniquely to this housekeeping. Deep non-REM sleep is central to the glymphatic system and physical repair, while REM sleep contributes to emotional integration and creative reorganization. Together, they form a balanced routine. The body is cleansed, the mind is edited, and emotions are softened. The alternation of these stages across the night ensures that no single task dominates, but that all are addressed in turn. In this sense, sleep is not a passive state, but a carefully scheduled maintenance cycle, one that nature has refined over countless generations. Housekeeping in the brain is not unique to humans. Studies in animals have shown similar processes at work, from the clearance of toxins in rodents to the pruning of synapses in birds. Even simpler creatures, such as fruit flies, show evidence of synaptic reorganization during rest-like states. This universality suggests that nightly maintenance is fundamental to nervous systems, necessary for survival in any creature that learns, remembers, and adapts. The fact that sleep has persisted through evolution despite its vulnerabilities when animals are less alert to predators underscores its importance. The benefits of brain housekeeping outweigh the risks of unconsciousness, making it indispensable for life. In reflecting on the brain's nightly housekeeping, one sees a picture of balance and renewal. The day fills the brain with impressions, connections, and waste, while the night clears, organizes, and restores. It is a rhythm as essential as breathing, one that operates beyond conscious awareness yet shapes every aspect of life. To awaken refreshed is to benefit from this hidden labor, to carry forward a mind that has been cleaned, balanced, and prepared for new experiences. The brain's housekeeping reminds us that even in rest, the body is working for us, maintaining the fragile order that allows thought, memory, and consciousness to flourish. Sleep, then, is not merely the absence of wakefulness. It is the time when the brain performs its most vital care, cleansing itself of waste, editing its memories, and resetting its chemistry. Each night, this hidden labor sustains the possibility of clear thought, stable mood, and long-term health. Without it, the brain falters. But with it, the mind emerges, each morning, ready to meet the world again. In the silent hours of the night, when consciousness drifts away, the brain continues its ceaseless work, tending to itself with the care of a patient custodian. It is a quiet labor, unseen but indispensable, the nightly housekeeping that keeps the mind whole. 10. Sleep and the body's repair. Sleep is often thought of as a state of stillness, a pause in activity, a quiet interval between the busy hours of the day. Yet beneath the calm exterior of a sleeping body, extraordinary processes unfold. The body uses the hours of sleep not merely to rest, but to repair, rebuild, and restore itself in ways that waking life cannot allow. Every system, from muscles to hormones to the immune defenses, is touched by this nightly renewal. To understand sleep as the body's repair workshop is to see how essential it is not only for feeling rested but for sustaining health and longevity. One of the most significant aspects of bodily repair during sleep is the release of growth hormone, secreted by the pituitary gland in pulses that peak during deep non-REM sleep. Growth hormone plays a central role in tissue repair and regeneration. In children and adolescents, it fuels physical growth, stimulating bones, muscles, and organs. In adults, it continues to be vital, repairing microscopic damage accumulated in tissues throughout the day. Muscles stressed by exertion or injury are rebuilt stronger. Collagen is replenished in the skin, and cells across the body are encouraged to divide and renew. This hormone-driven repair helps explain why sleep is so restorative for athletes, whose performance and recovery are closely tied to its quality and duration. The immune system also depends deeply on sleep for its nightly maintenance. During rest, the body increases the production of cytokines, proteins that help regulate immune responses. These molecules direct the activity of immune cells, enabling them to identify and combat pathogens more effectively. Sleep deprivation, on the other hand, reduces the production of these protective proteins, weakening resistance to infection. Studies have shown that individuals who do not get sufficient sleep are more likely to fall ill after exposure to viruses such as the common cold. Vaccines, too, appear to be more effective in well-rested individuals, suggesting that sleep enhances the body's ability to form lasting immune memories. In this way, every night of sufficient sleep strengthens the body's invisible shield against disease. Another important aspect of repair is the regulation of metabolism and energy balance. During sleep, the body adjusts its use of insulin, the hormone that regulates blood sugar. Adequate rest keeps cells sensitive to insulin, ensuring that glucose can be used efficiently as fuel. When sleep is cut short, insulin sensitivity decreases, and blood sugar levels rise, setting the stage for metabolic disorders such as diabetes. In addition, sleep influences the hormones that control appetite: ghrelin, which stimulates hunger, and leptin, which signals fullness. Lack of sleep shifts their balance, increasing appetite and reducing satiety, leading to overeating and weight gain. Thus, the repair work of sleep extends beyond tissues and organs into the very regulation of energy, helping the body maintain balance in its most basic processes. The cardiovascular system also benefits from sleep's restorative effects. During deep sleep, blood pressure decreases, heart rate slows, and the cardiovascular system experiences a period of rest. This nightly dip gives blood vessels and the heart time to recover from the constant demands of waking activity. Sleep also supports the repair of the lining of blood vessels, maintaining their flexibility and reducing the risk of damage that could lead to hypertension or atherosclerosis. When sleep is insufficient, these restorative periods are shortened, placing continuous strain on the heart and vessels. Over time, chronic sleep deprivation is associated with increased risks of heart disease, stroke, and other cardiovascular problems. The nightly restoration of the heart is thus a vital part of sleep's repair function, ensuring endurance across a lifetime. Even the skin, the body's largest organ, engages in repair during sleep. Collagen production increases, helping to maintain elasticity and strength. Blood flow to the skin rises, carrying nutrients that support healing and renewal. This is why wounds often heal more effectively when the body is well rested, and why sleep deprivation can leave the skin looking pale, lined, or dull. The phrase beauty sleep has a basis in biology. Without sufficient rest, the processes that rejuvenate the skin are disrupted, and the visible effects quickly appear. Over time, chronic lack of sleep contributes to premature aging, as the nightly cycles of repair are cut short. The nervous system itself, beyond the brain's cleansing functions, also undergoes repair during sleep. Nerve cells restore their energy reserves, repair their membranes, and strengthen their synaptic connections. Peripheral nerves that carry signals to and from muscles and organs are maintained through this nightly process. This contributes not only to learning and memory, but also to the smooth functioning of reflexes, coordination, and sensation. The body's ability to respond to its environment depends on this nightly restoration of the nervous system. Hormonal balance is another critical area where sleep exerts its influence. In addition to growth hormone, sleep regulates cortisol, the body's primary stress hormone. Cortisol follows a daily rhythm, reaching its lowest levels during early sleep and rising toward morning to help prepare the body for waking. Disruption of this rhythm by insufficient sleep or irregular schedules leaves cortisol elevated at night, straining the body's repair mechanisms and increasing stress on tissues. Over time, this imbalance contributes to inflammation, impaired immunity, and metabolic dysfunction. Sleep restores not only tissues, but also the timing of hormones, maintaining the delicate cycles that keep the body in harmony with its environment. Sleep's role in repair is not limited to physical processes. It extends to emotional and psychological restoration as well. While the brain's emotional circuits are reorganized during REM sleep, the body's stress responses are also quieted. Heart rate variability improves, indicating a more flexible and resilient nervous system. This resilience translates into physical health, as the body responds more effectively to stressors and recovers more quickly from them. In this way, emotional repair and physical repair are intertwined, each supporting the other through the work of sleep. The consequences of neglecting this nightly repair are profound. Chronic sleep deprivation weakens immunity, slows wound healing, increases the risk of metabolic and cardiovascular disease, and accelerates aging. The body, denied its chance to recover, begins to break down under the strain of constant activity without sufficient restoration. Even small deficits, accumulated night after night, create a burden that gradually erodes health. Conversely, prioritizing sleep allows the body to keep pace with the demands of life, repairing the inevitable wear and tear of daily existence. Reflecting on sleep as the body's repair mechanism invites a shift in perspective. Sleep is not wasted time, but an essential investment in health. It is the nightly maintenance that allows the heart to beat steadily, the muscles to remain strong, the skin to stay resilient, and the immune system to stand guard. Without it, the body falters. With it, the body thrives. Each night, as we surrender to rest, the hidden workshop of the body begins its work, guided by rhythms older than memory, ensuring that we awaken, renewed. In the quiet hours of sleep, the body remembers how to heal. Cells divide, tissues rebuild, hormones reset, and the immune system sharpens its defenses. The labor is invisible, unfolding silently, but its results are felt each morning in the strength to move, the clarity to think, and the resilience to endure. Sleep is the body's most profound act of self-care, the nightly restoration that sustains life itself. It is the foundation upon which health rests, the silent repair that prepares us, again and again, to meet the light of day. 11. Circadian rhythms and biological clocks. Life on Earth has always unfolded under the steady alternation of day and night. From the earliest organisms that drifted in ancient seas to the complex beings that now walk the planet, this rhythm of light and darkness has been a constant, shaping the evolution of every living system. Within the human body, this rhythm is reflected in the circadian cycle, an internal clock that governs not only when we feel awake and when we feel tired, but also countless subtle processes, from body temperature to hormone release, from digestion to immune function. To understand sleep, one must first understand this clock, for sleep does not arise randomly, but follows the rhythm set by nature itself. The word circadian comes from the Latin circa diem, meaning about a day. It describes biological cycles that repeat roughly every 24 hours, synchronized with the turning of the earth. While many processes in the body follow their own cycles, some faster, some slower, the circadian rhythm is the overarching pattern that aligns human activity with the external world. It is most clearly expressed in the sleep-wake cycle, the tendency to be alert during daylight and to grow drowsy after dark. Yet beneath this simple alternation lies a sophisticated system of timing that orchestrates the body's functions in harmony with the environment. At the heart of the circadian rhythm is a small cluster of neurons in the brain called the suprachiasmatic nucleus, or SCN, located in the hypothalamus, just above the optic nerves. The SCN receives direct input from the eyes. Light signals detected by specialized cells in the retina are transmitted to this central clock, allowing it to synchronize with the cycle of day and night. In this way, the body knows when it is morning, when it is evening, and how to adjust its processes accordingly. The SCN, in turn, sends signals throughout the body, coordinating the activity of organs and tissues so that they function in unison with the external world. One of the most important outputs of the circadian system is the regulation of melatonin, the hormone often called the sleep hormone. As daylight fades, the SCN signals the pineal gland to begin releasing melatonin into the bloodstream. Rising melatonin levels prepare the body for sleep, lowering body temperature, reducing alertness, and signaling that night has arrived. As morning light returns, melatonin secretion diminishes, clearing the way for wakefulness. This daily rise and fall of melatonin provides the body with a reliable signal of time, helping to align internal rhythms with external cues. The circadian rhythm does not only influence sleep. Body temperature, for instance, follows a daily pattern, typically peaking in the late afternoon and reaching its lowest point in the early hours of the morning. This fluctuation contributes to alertness during the day and to sleepiness at night. Hormones such as cortisol also follow circadian patterns, with levels rising before dawn to promote wakefulness and energy, then falling in the evening to allow rest. Even digestion and metabolism are shaped by circadian timing. Insulin sensitivity, appetite, and digestive enzyme activity all vary depending on the time of day. In this way, the circadian rhythm provides a framework within which countless processes unfold, keeping the body in sync with its environment. Disruptions to this natural rhythm can have profound effects. When people work night shifts or travel across time zones, their internal clocks can fall out of sync with external light cues, creating a condition known as circadian misalignment. The result is often fatigue, irritability, digestive upset, and difficulty concentrating, commonly experienced as jet lag. If such disruptions are prolonged, they can increase the risk of chronic health problems, including cardiovascular disease, obesity, diabetes, and mood disorders. This is because the circadian system not only governs sleep, but also coordinates essential metabolic and hormonal processes that sustain health. When the timing is disturbed, the entire system is strained. The sensitivity of the circadian system to light is both its strength and its vulnerability. Natural sunlight provides a reliable signal, but in the modern world, artificial light complicates the picture. Exposure to bright screens and indoor lighting late at night can delay melatonin release, pushing the body's rhythm later than the natural cycle. This can lead to difficulty falling asleep, reduced sleep quality, and a misalignment between internal time and external obligations. Conversely, bright light exposure in the morning can strengthen circadian rhythms, improving alertness and promoting healthy sleep patterns. Thus, the management of light has become an important consideration in maintaining circadian health. Circadian rhythms are not identical in all individuals. Genetics, age, and lifestyle create differences in timing that are often described as chronotypes. Some people are naturally inclined to wake early and feel most energetic in the morning, so-called larks. Others prefer late nights and find their peak alertness in the evening, known as owls. Most people fall somewhere in between. These differences are not merely habits, but reflect real variations in the timing of circadian processes. Respecting one's chronotype can improve well-being, while forcing the body into unnatural schedules often leads to fatigue and reduced performance. As people age, their chronotypes also change, with adolescents tending toward later rhythms and older adults often returning to earlier ones. Interestingly, circadian rhythms are not limited to the central clock in the brain. Virtually every cell in the body contains molecular clocks, genes, and proteins that oscillate in daily cycles. These peripheral clocks regulate local processes such as liver metabolism, muscle repair, or immune cell activity. While the SCN provides overall coordination, these local clocks keep time independently, ensuring that each tissue carries out its functions at the appropriate moment. For example, the liver processes nutrients more efficiently during the day when food intake is expected, while the immune system ramps up certain defenses at night. This distributed system of clocks highlights the complexity of circadian biology and underscores why misalignment affects health so broadly. The study of circadian rhythms has also led to practical applications in medicine and daily life. Doctors have discovered that the timing of medication can influence its effectiveness, a field known as chronotherapy. Certain drugs work better when taken at times that align with the body's natural rhythms, while others may cause fewer side effects if timed appropriately. In workplaces, recognition of circadian principles has led to shifts in scheduling practices, with efforts to reduce long-term night work or to provide light exposure that helps align internal clocks. Even in education, awareness of adolescent chronotypes has raised questions about school start times, with evidence suggesting that later starts improve learning and health. Beyond the practical, the circadian rhythm carries a quiet poetry. It reflects the deep bond between living beings and the cycle of the earth. The rising and setting of the sun, which has marked time since long before humans appeared, continues to shape our biology at every level. Each morning, the body is primed for activity, energy, and engagement. Each evening, it is guided gently into rest, repair, and renewal. This daily rhythm ties human life to the turning of the planet, a reminder that even in an age of artificial light and constant motion, we remain children of the Earth's cycle. In the end, circadian rhythms and biological clocks show us that sleep is not an isolated phenomenon, but part of a larger symphony of timing. The body is not a machine that can operate endlessly at the same pace, but a living system tuned to cycles of activity and rest. To live in harmony with these rhythms is to support health, clarity, and vitality. To ignore them is to invite imbalance and strain. Each night, when sleep arrives in its natural time, we are not only resting but aligning ourselves with the deep rhythm of life itself. This alignment maintained quietly by the ticking of countless cellular clocks, sustains us as surely as breath and heartbeat. 12. The role of lucid dreaming. Among the many mysteries of sleep, lucid dreaming occupies a special and almost magical place. Unlike ordinary dreams, in which the dreamer is swept along by shifting scenes and strange events without questioning their reality, a lucid dream is one in which awareness returns. The dreamer realizes, sometimes suddenly and sometimes gradually, that what they are experiencing is not waking life, but a dream. In this state, the impossible reveals itself as possible. The dreamer may choose to fly, to speak with long-lost loved ones, or to shape the unfolding narrative of the dream. Lucid dreaming is both rare and familiar, blending the unconscious world of sleep with the self-awareness of waking life. Modern science has studied this phenomenon with great curiosity, uncovering clues about consciousness, creativity, and the hidden potential of the mind. The first written accounts of lucid dreaming appear in ancient texts. Philosophers in Greece and Rome, Buddhist monks in India, and Taoist practitioners in China all recorded experiences of being aware within their dreams. For them, these states were often seen as opportunities for spiritual practice, a chance to explore the nature of the self and the illusion of reality. Tibetan Buddhists developed dream yoga, a discipline that used lucid dreaming as a path to enlightenment, encouraging practitioners to recognize the dreamlike quality of both night and day. These traditions recognized what science has only recently confirmed, that the line between waking and dreaming is not as rigid as it appears, and that awareness can sometimes bridge the divide. Lucid dreaming is thought to occur most often during REM sleep, the stage of sleep when dreams are most vivid, and brain activity most resembles wakefulness. In this state, the brain's visual and emotional centers are highly active, but the prefrontal cortex, associated with self-awareness and logic, is usually subdued. In lucid dreams, however, activity in parts of the prefrontal cortex increases, allowing the dreamer to recognize the dream state. Researchers have confirmed this by studying brain scans of lucid dreamers and by training them to signal their awareness with predetermined eye movements during sleep. These signals, recorded while the dreamer is still in REM, prove that awareness within a dream is not an illusion, but a measurable reality. The experience of lucidity can vary widely. For some, it is a fleeting recognition, a moment of awareness that quickly fades as the dream reasserts its hold. For others, it becomes a sustained experience in which the dreamer can influence events, explore environments, or even practice skills. People often describe lucid dreams as intensely vivid, more colorful and memorable than ordinary dreams. The sense of freedom of being able to choose within a limitless world can be exhilarating. Yet lucidity does not always bring control. Sometimes the dream continues on its own path, with the dreamer simply observing it knowingly. Other times, efforts to change the dream collapse it altogether, leading to awakening. The delicate balance between awareness and immersion is part of what makes lucid dreaming so fascinating. Scientists have studied whether lucid dreams can be deliberately induced. Certain techniques, such as reality testing during the day, aim to increase the likelihood of recognizing a dream. For example, one might regularly ask, "Am I dreaming?" while awake, in the hope that the habit carries into dreams. Other methods involve waking briefly in the middle of the night before returning to sleep, a strategy that increases the chances of entering REM with awareness. Some research has explored the use of external cues such as flashing lights or sounds presented during REM that may be incorporated into dreams as signals to become lucid. While these methods vary in effectiveness, they suggest that lucidity is not entirely random, but can be cultivated with practice. Lucid dreaming has attracted attention not only for its curiosity, but for its potential benefits. One area of interest is the treatment of nightmares. For individuals who suffer from recurring distressing dreams, the ability to recognize and alter the dream can provide relief. By becoming aware that a threatening figure or situation is not real, dreamers can confront or transform it, reducing fear and breaking the cycle of nightmares. Clinical studies have shown that training in lucid dreaming can help patients with post-traumatic stress disorder, giving them a sense of control in a domain that once felt overwhelming. In this way, lucidity becomes a form of therapy, reshaping the emotional landscape of sleep. Another potential benefit lies in skill rehearsal. Because the brain regions involved in motor activity are active during dreams, practicing a skill in a lucid dream may reinforce the same neural pathways as practicing it while awake. Athletes, musicians, and performers have reported using lucid dreams to rehearse movements or techniques, finding that the mental practice carries over into waking performance. While this remains an area of ongoing research, it highlights the remarkable continuity between dreaming and waking cognition. The dream world, far from being isolated, interacts with the same systems that support real-world learning and memory. Lucid dreams also offer a window into the nature of consciousness itself. They reveal that self-awareness is not confined to waking life but can arise in altered states. In lucidity, the dreamer becomes both subject and observer, aware of the dream while also immersed in it. This dual perspective raises profound questions about the flexibility of awareness and the boundaries of reality. If one can recognize the dream while dreaming, might one also recognize the dreamlike qualities of waking life? Such reflections echo the teachings of ancient philosophers and mystics, who saw dreams as metaphors for existence itself. Modern neuroscience may not answer such questions directly, but it acknowledges the extraordinary insight that lucid dreams provide into the workings of the mind. Despite their allure, lucid dreams are relatively rare for most people. Surveys suggest that while many individuals have experienced lucidity at least once, few experience it regularly. For those who do, the frequency may vary from occasional episodes to several times a month. The rarity of lucid dreams adds to their sense of wonder, making them memorable events that stand out in the flow of nightly sleep. Some people seek them deliberately, practicing techniques to increase their likelihood, while others encounter them only by chance, surprised each time by the sudden realization of awareness. Lucid dreaming also highlights the interplay between control and surrender. While the dreamer may exert influence, the dream is not fully under command. It remains a creation of the unconscious mind, shaped by hidden thoughts, emotions, and memories. Even in lucidity, surprises abound, reminding the dreamer that the dream world, like waking life, is larger than the self. This balance between agency and mystery is part of what makes lucid dreaming both empowering and humbling, offering glimpses of freedom within a realm still guided by deeper currents. Ultimately, the role of lucid dreaming in human life may not be to provide escape or power, but to remind us of the vastness of the mind. It shows that awareness can arise in unexpected places, that imagination can create worlds as vivid as waking reality, and that within sleep lies not only rest but exploration. For those who experience it, lucidity brings a sense of wonder, a reminder that even in the most familiar of states, sleep, there are still mysteries waiting to be discovered. Each night, as we drift into REM sleep, the possibility of lucidity lies dormant, a chance that awareness may bloom within the dream. Whether fleeting or sustained, whether guided or observed, lucid dreams reveal the hidden flexibility of consciousness. They remind us that sleep is not only a time for repair and consolidation, but also a time for exploration, where the mind, free from external limits, can wander its own landscapes with open eyes. Lucid dreaming is the meeting place of rest and awareness, a rare but profound reminder that the boundaries of experience are wider than we imagine. 13. Sleep disorders gently considered. While sleep is one of the most natural processes of life, flowing in quiet cycles from childhood through old age, it does not always unfold smoothly. For many people, the night brings disturbances, moments when the rhythm falters, when sleep is delayed, fragmented, or disrupted in ways that affect both body and mind. These conditions, broadly known as sleep disorders, are not unusual, and they reveal much about the delicate nature of rest. To consider them gently is to see not only the challenges they present, but also the ways in which they highlight the importance of sleep itself. Just as occasional storms remind us of the atmosphere that usually sustains us, so do sleep disorders remind us of the fragile balance that allows each night's renewal. One of the most common disturbances is insomnia, the difficulty of falling asleep or staying asleep. For some, it arises only occasionally, perhaps during times of stress or excitement. For others, it becomes chronic, stretching across weeks or months. Insomnia can take many forms: lying awake for long stretches, waking too early in the morning, or drifting into restless, shallow sleep that brings little refreshment. The causes are varied: stress, anxiety, irregular schedules, medical conditions, or environmental factors, such as noise and light. Though frustrating, insomnia does not diminish the body's need for sleep. Rather, it emphasizes how sensitive sleep is to both inner and outer influences. The mind may replay worries long after the day has ended, keeping the body alert when it should rest. In such moments, the very awareness of needing sleep can make it elusive, creating a cycle of wakefulness that reinforces itself. Another condition, sleep apnea, interrupts sleep with brief pauses in breathing, often unnoticed by the sleeper but evident to a partner. These pauses may last only seconds but occur dozens or even hundreds of times per night. Each interruption briefly wakes the brain, preventing deep restorative sleep. The body struggles for air, oxygen levels dip, and the heart works harder than it should. Over time, untreated sleep apnea can contribute to fatigue, high blood pressure, and cardiovascular strain. Yet it is also treatable, often with simple adjustments such as changes in posture, weight management, or the use of devices that keep airways open. Apnea illustrates how closely sleep is tied to the body's most basic rhythms of breath and circulation, and how even small disruptions can ripple into broader effects. Some disturbances occur not in the quiet stillness of sleep, but in movements that escape from its depths. Sleepwalking, for example, arises during deep non-REM sleep, when the body is usually most still. In this state, the sleeper may rise, walk, or perform simple actions, often with no memory upon waking. For children, sleepwalking is relatively common and often fades with age. For adults, it may persist or return, sometimes triggered by stress or irregular sleep. Though usually harmless, it reflects the complexity of sleep's architecture. Even in deep rest, the brain can allow fragments of motor activity to emerge. Similarly, sleep-talking utterances made during sleep reminds us that speech, too, may slip into the night, carrying echoes of thought into the quiet. Night terrors, another condition of childhood, occur during deep sleep as well. Unlike nightmares, which arise in vivid REM sleep and are often remembered, night terrors involve sudden arousal, intense fear, and confusion, with little or no memory afterward. A child may cry out, sit up, or appear distressed, though still asleep. For parents, such episodes can be alarming, but for the child, they are often forgotten by morning. Night terrors reveal how emotions can surge even in states far removed from ordinary awareness, showing that sleep is not always the calm retreat it seems. Narcolepsy presents a different kind of challenge. characterized by sudden and overwhelming sleepiness during the day. Individuals with narcolepsy may fall asleep abruptly, sometimes in the midst of conversation or activity. This condition reflects a disruption in the regulation of sleep-wake cycles, with REM sleep intruding unexpectedly into waking life. Narcolepsy may also involve cataplexy, a sudden loss of muscle tone often triggered by strong emotion, leaving the individual temporarily unable to move. Though rare, narcolepsy illustrates how closely linked emotion and sleep are, and how fragile the boundaries between wakefulness and dreaming can become. Treatments can help regulate these rhythms, but the condition underscores the deep complexity of the systems that govern rest. Restless leg syndrome is another condition that affects the transition into sleep. It involves uncomfortable sensations in the legs, often described as tingling, crawling, or pulling, accompanied by an irresistible urge to move. These sensations typically worsen at night, making it difficult to fall asleep and remain still. Though the cause is not fully understood, it may involve imbalances in brain chemistry, particularly dopamine. The relief that comes from movement highlights the tension between the body's desire for rest and the nervous system's insistence on activity. Like other sleep disorders, it shows how finely balanced the body must be for sleep to unfold naturally. While each disorder has its own characteristics, they all share a common thread. They interrupt the natural flow of sleep, preventing the cycles of restoration from unfolding smoothly. The consequences are often similar: fatigue, difficulty concentrating, irritability, and a general sense of being unrefreshed. Over time, chronic disturbances can strain physical health, increasing the risk of illness and weakening resilience. Yet it is important to remember that sleep disorders are not failures of will or character, but reflections of the body's complexity. They remind us that sleep is not something we command directly, but something we prepare for and allow. The gentle consideration of sleep disorders also involves recognizing how widespread they are. Many people experience them at some point, whether temporarily or persistently. In modern society, with its artificial lights, irregular schedules, and constant stimulation, disturbances of sleep are especially common. The body, evolved to follow the rhythm of sun and darkness, often struggles when that rhythm is ignored. Sleep disorders, in this sense, are not simply medical conditions but cultural signals, reflecting the ways in which modern life can pull against natural cycles. At the same time, the resilience of sleep should not be underestimated. With attention to habits, environment, and rhythm, many disturbances can be softened or resolved. Simple measures such as reducing evening light exposure, keeping consistent schedules, and creating calm spaces for rest can make profound differences. Where disorders persist, medical support can offer treatments that restore balance. In every case, the goal is not to force sleep but to invite it, to create conditions in which the body's natural rhythms can return. To think of sleep disorders gently is to see them not only as challenges but as teachers. They show how essential sleep is, how sensitive it can be to disruption, and how deeply it is tied to the body's health. They remind us that sleep is both fragile and resilient, vulnerable to disturbance yet always seeking restoration. Each night, despite interruptions, the body strives to return to its cycles, to repair and renew. Even when disorders arise, they highlight the miracle of ordinary sleep, the smooth flow of cycles that, when undisturbed, carry us through the night without effort or awareness. In the end, sleep disorders remind us of the balance that sleep represents. They reveal the hidden labor that must unfold each night for the body to heal and the mind to refresh. They show that when this labor is interrupted, the consequences ripple into waking life. Yet they also point to the possibility of recovery, to the capacity of the body to restore itself when given the chance. To consider them gently is to recognize both their challenges and their lessons, and to appreciate even more the gift of a peaceful night's rest. 14. The connection between sleep and emotion. Sleep and emotion are bound together in ways both subtle and profound. Each influences the other, forming a cycle that can sustain balance or deepen imbalance. When sleep is sufficient, emotions are tempered, softened, and integrated into memory. When sleep is lacking, feelings often become sharp, unstable, or overwhelming. The rhythms of the night shape the moods of the day, while the moods of the day shape the ease of the night. To understand this relationship is to recognize that rest is not only physical but emotional, and that every dream and every cycle of sleep participates in the delicate work of maintaining the inner life. From the moment we awaken, our emotional state is shaped in part by how we slept. A good night of rest tends to bring calm, steadiness, and resilience. Challenges feel more manageable, irritations less sharp, joys more accessible. In contrast, a poor night of sleep leaves the mind vulnerable. Even small frustrations can feel overwhelming. Moods swing more quickly, and the ability to regulate feelings weakens. This shift is not merely psychological but biological. Brain imaging studies show that sleep deprivation heightens activity in the amygdala, the region of the brain that processes fear, anger, and other strong emotions. At the same time, it reduces the moderating influence of the prefrontal cortex, which normally tempers emotional responses with logic and perspective. The result is an emotional system running unchecked, prone to exaggeration and volatility. Yet sleep does more than simply blunt or sharpen emotions, it helps process them. During both non-REM and REM sleep, emotional experiences from the day are replayed and reorganized. The brain does not erase these experiences, but integrates them into the broader landscape of memory. The sharpness of emotion is softened, while the meaning is preserved. This allows a person to remember what happened without being overwhelmed by how it felt. For example, a stressful event may replay in a dream, but in the protected context of sleep, the body is shielded from the full force of stress hormones. Over repeated nights, the event becomes part of one's narrative without continually triggering the nervous system. Sleep acts like a gentle counselor, revisiting experiences until they can be carried without pain. REM sleep, in particular, seems central to this work. During this stage, the brain is active, dreams are vivid, and the amygdala once again shows strong activity. But unlike during wakefulness, the body's stress chemistry is dampened. The stress hormone norepinephrine, which fuels the fight or flight response, is nearly absent in REM sleep. This creates a unique state in which the brain can revisit emotionally charged material without reactivating the full stress response. Scientists describe this as overnight therapy. It explains why time and sleep together often ease grief, fear, or anger. The memory of the event remains, but its emotional burden is lighter. This nightly therapy helps maintain mental health, preventing emotions from becoming stuck or overwhelming. Dreams play a role in this process as well. Though often strange and fragmented, dreams frequently draw upon emotionally significant themes, relationships, fears, desires, or unresolved conflicts. They present these themes in symbolic or exaggerated forms, offering the mind opportunities to explore them from different perspectives. Some dreams provide direct rehearsals of real situations, while others transform emotions into surreal imagery. In either case, the emotional charge is engaged and processed, leaving the sleeper subtly changed. Many people notice that after a particularly vivid dream, their mood shifts in ways they cannot entirely explain, as if the mind has worked through something hidden. This is one of the quiet gifts of dreaming. It allows emotions to find new forms, new meanings, and sometimes even resolution. The connection between sleep and emotion is also evident in mental health. Conditions such as depression, anxiety, and post-traumatic stress disorder are often accompanied by disruptions in sleep. In depression, people may experience early morning awakenings, reduced deep sleep, or excessive REM sleep. In anxiety, difficulty falling asleep and restless awakenings are common. In PTSD, nightmares replay traumatic events with relentless vividness. These conditions show how deeply emotions and sleep interact, each influencing and reinforcing the other. Restoring healthy sleep can ease emotional distress, while treating emotional conditions often improves sleep. The two are intertwined, inseparable parts of the same system. Children and adolescents provide another window into this connection. Young people, whose emotional systems are still developing, rely heavily on sleep to regulate mood. Studies show that adolescents who do not get sufficient sleep are more likely to experience irritability, sadness, and difficulty managing stress. Their developing brains, particularly in regions that regulate emotion, are especially vulnerable to sleep loss. This may explain why mood swings are common in teenagers who keep irregular sleep schedules. For children, naps serve a similar function, helping them regulate the flood of new experiences and emotions that come with rapid growth. In each case, sleep provides the foundation for emotional stability. Even in daily life, the link between sleep and emotion is clear. People often speak of needing to sleep on it before making an important decision. This wisdom reflects the way sleep helps integrate feelings with reason. A problem that seems unsolvable at night may feel clearer by morning, not only because the brain has processed information, but also because the emotional weight has shifted. Arguments that feel heated at night often cool after rest, while joys experienced during the day can be savored again in dreams. Sleep allows emotions to settle into perspective, making them less overwhelming and more manageable. The cycle between sleep and emotion is not one-directional. Just as sleep shapes emotion, emotion shapes sleep. Stressful days often lead to restless nights, as the body remains in a state of alertness even when the mind seeks rest. Anxiety can keep the nervous system activated, delaying sleep or causing frequent awakenings. Sadness can disrupt rhythms, leading to either excessive sleep or difficulty maintaining it. In this way, emotions feed back into sleep, sometimes creating cycles that are difficult to break. Recognizing this connection helps explain why relaxation, stress management, and emotional support are important for healthy sleep. Despite these challenges, the resilience of the sleep-emotion system is remarkable. Even after difficult days, the body seeks balance during the night, striving to regulate stress and restore calm. When given the opportunity, sleep naturally works to heal emotional wounds, to soften sharp feelings, and to renew perspective. This is why consistent sleep, protected from disruption, is one of the most powerful supports for mental well-being. It is not a luxury but a necessity, as vital as nutrition or exercise in sustaining emotional health. To reflect on the connection between sleep and emotion is to see sleep not simply as the absence of wakefulness, but as an active process of healing. Each night, emotions are revisited, tempered, and integrated, leaving the sleeper better prepared for the challenges of another day. The laughter of joy, the weight of grief, the pangs of fear, all are carried into the night and gently reshaped until they can be borne more lightly. Without this nightly therapy, emotions can accumulate, overwhelming the mind and body. With it, life regains balance, and the spirit is renewed. In the quiet hours of sleep, emotions find their place. The storms of the day are eased, the joys are remembered, the sorrows softened. Sleep gives space for the heart as well as the body, providing restoration that no waking effort can replace. Each morning, when we rise calmer, steadier, and more resilient, we are witnessing the fruit of this hidden work. Sleep and emotion, inseparable companions, remind us that to rest is not only to restore the body, but to heal the soul. 15. Sleep across the animal kingdom. Sleep, though universal, takes many forms across the animal kingdom. From the smallest insects to the largest mammals, nearly all creatures experience periods of rest that resemble sleep, though the ways in which it unfolds vary greatly. This diversity reveals both the ancient roots of sleep and its vital importance to life. If sleep were unnecessary, it would have been abandoned by evolution long ago. Instead, it has persisted and adapted, shaped by the needs and environments of countless species. To explore sleep across animals is to glimpse the many strategies life has developed for balancing activity with restoration, wakefulness with rest. Among mammals, sleep most closely resembles our own, though with fascinating variations. Dogs and cats, for example, spend long hours asleep, often more than half the day. Their slumber is lighter than ours, with frequent awakenings, reflecting their ancestral need to remain alert to danger or opportunity. Anyone who has watched a sleeping cat twitch its whiskers or paddle its paws has witnessed REM sleep, the stage of vivid dreaming. Horses, on the other hand, can sleep both lying down and standing up, thanks to special tendons and ligaments in their legs that lock their joints, allowing them to rest without collapsing. Yet even horses must lie down for deeper phases of sleep, reminding us that no creature can entirely escape the pull of true rest. Elephants provide another striking example. Despite their size and the immense demands of their bodies, elephants sleep only a few hours each night, often standing and sometimes lying down. They spend so much time eating to sustain their bulk that little remains for rest. Yet within those few hours, they still pass through cycles of REM and non-REM sleep. Their dreams, though unknowable to us, may carry the same vividness as ours, hinted at by their twitching trunks and shifting eyes. Bats present the opposite extreme, sleeping up to 20 hours a day, their energy conserved as they hang motionless in caves. The contrast between elephants and bats illustrates the flexibility of sleep, molded to each species' needs. Marine mammals face unique challenges, for they cannot remain fully unconscious without risking drowning. Dolphins and whales have evolved a remarkable solution: unihemispheric slow-wave sleep. In this state, half of the brain rests while the other half remains awake enough to control breathing and watch for predators. One eye remains open, connected to the active hemisphere, while the other closes. Later, the roles reverse. This adaptation allows marine mammals to sleep while continuing to swim, surface for air, and remain vigilant. Birds share a similar ability, using unihemispheric sleep during migration or while resting in groups, keeping one eye open to monitor the surroundings. These strategies reveal how flexible sleep can be, adjusting to environments where complete vulnerability would be dangerous. Insects, too, display sleep-like states, though less easily observed. Fruit flies, often studied in laboratories, show cycles of rest and activity that meet the criteria for sleep: reduced movement, lowered responsiveness, and a need for recovery if deprived. Their sleep is influenced by circadian rhythms and is essential for memory, much like in humans. Bees rest at night, with their antennae drooping and their bodies still, conserving energy for the intense labor of the day. These simple forms of rest highlight how deeply rooted sleep is in life, extending even to creatures with nervous systems far simpler than ours. Reptiles and amphibians also experience sleep, though their patterns differ. Lizards, for example, show alternating phases of brain activity that resemble the non-REM and REM cycles of mammals, suggesting that these stages may have evolved earlier than once believed. Frogs and other amphibians rest with reduced responsiveness, though their sleep patterns are influenced strongly by temperature and environment. The diversity of these patterns emphasizes that while sleep is nearly universal, it is shaped by each species' ecological niche. Birds present a particularly fascinating case. Their sleep is generally shorter and lighter than that of mammals, yet it is remarkably adaptable. Many migratory birds, such as swifts and frigate birds, can sleep while flying. They rely on brief episodes of unihemispheric sleep, allowing them to rest while still navigating the skies. During breeding seasons, some species dramatically reduce their sleep without apparent harm, suggesting that sleep needs can adjust in response to life's demands. Still, even birds require REM sleep, though their episodes are shorter than those of mammals. This reveals that dreaming, or at least the brain activity associated with it, is not unique to humans but may be widespread among animals. Fish, though lacking eyelids, also experience rest states that resemble sleep. They become still, often hovering in one place, or retreating into hiding spots, their responsiveness lowered. Some fish even build protective shelters for sleep, such as the parrotfish, which secretes a mucus cocoon to shield itself from predators while resting. Though their brains differ greatly from ours, the presence of these restful states reinforces the idea that sleep is a fundamental requirement for neural function, even in aquatic environments. What unites these diverse forms of sleep is not uniformity but necessity. Each species has developed strategies to balance rest with survival, but none can eliminate sleep entirely. Whether through long hours of deep rest, brief episodes scattered through the day, or the use of only half the brain at a time, sleep persists. This persistence suggests that its functions repair, memory consolidation, emotional regulation, and cleansing are so vital that they cannot be sacrificed, no matter the evolutionary pressures. The study of animal sleep also sheds light on human sleep. By comparing patterns across species, scientists gain insight into which aspects of sleep are ancient and which are more specialized. The presence of REM-like states in reptiles and birds suggests that dreaming may have deep evolutionary roots. The adaptability of sleep in birds and dolphins shows that the brain can achieve rest even in challenging environments, hinting at mechanisms humans might one day better understand. Animal sleep reminds us that our own nightly cycles are part of a much larger tapestry, woven across the entire history of life. Beyond science, there is also poetry in the thought of sleep across the animal kingdom. One can imagine the quiet of a forest at night, with deer resting in the shadows, owls half asleep on branches, and small mammals curled in their burrows. Beneath the waves, dolphins drift with one eye closed, and fish float motionless in the dim light. In distant caves, bats hang silent, while above the clouds, birds continue their journeys with half their minds at rest. Sleep connects all of these creatures, linking them in a shared rhythm that transcends species and habitat. In reflecting on sleep across animals, we see both the diversity of life and the unity of its needs. Sleep takes many forms, yet its purpose endures: to restore, to balance, to sustain. It is as necessary for the tiny fruit fly as for the mighty elephant, as vital for the migrating bird as for the resting child. Sleep is one of life's great common denominators, a reminder that beneath all differences, every living being must pause, surrender, and renew. To sleep is to participate in a rhythm older than species, older than memory, a rhythm shared across the kingdom of life. 16. The evolution of sleep. To understand why sleep exists in all its forms, from the stillness of humans to the drifting rest of dolphins and the quiet pauses of insects, one must look back through the vast expanse of evolutionary time. Sleep is not a recent invention of complex animals, but a process with roots that stretch deep into the history of life itself. Its persistence across species suggests that it serves fundamental purposes, without which survival would be impossible. If sleep were wasteful or unnecessary, natural selection would have reduced or eliminated it. Instead, it has been preserved, refined, and adapted across millions of years, appearing in creatures as different as flies, birds, and whales. To reflect on the evolution of sleep is to glimpse how nature shaped a process so universal and yet so diverse, one that bridges ancient biology with modern experience. The origins of sleep-like states can be traced to some of the simplest organisms. Even creatures without brains, such as jellyfish, exhibit periods of inactivity that resemble primitive sleep. These states involve reduced responsiveness, rhythmic cycles tied to light and darkness, and the need for recovery if disrupted. The fact that such patterns appear in organisms lacking complex nervous systems suggests that the roots of sleep may lie not in dreaming or memory consolidation, but in the basic regulation of energy and cellular repair. In early life, conserving energy during the night may have provided an evolutionary advantage, allowing cells to focus on growth and restoration when conditions were less favorable for activity. As nervous systems evolved, sleep became more sophisticated. Insects such as fruit flies show clear evidence of sleep-like behavior. They enter states of immobility, become less responsive to stimuli, and show signs of memory impairment when deprived. Flies even display circadian rhythms, resting during regular intervals tied to cycles of light and darkness. These findings suggest that the core functions of sleep restoration and memory processing emerged early, long before mammals or even vertebrates appeared. Sleep in insects may not involve the complex stages seen in humans, but its presence demonstrates how deeply embedded rest is in the biology of life. Among vertebrates, sleep began to display more structured patterns. Fish, amphibians, and reptiles all show states that parallel aspects of mammalian sleep, though their brain activity differs. Lizards, for example, alternate between phases of quiet rest and more active states resembling REM sleep, hinting that the architecture of sleep developed earlier than once thought. This alternation suggests that even in ancient reptiles, sleep had already diversified into stages that served different purposes, perhaps one for physical restoration and another for memory or emotional processing. Such division of labor would have provided clear survival benefits, refining the efficiency of rest. Birds provide another important chapter in the story of sleep's evolution. Their sleep, like that of mammals, includes both non-REM and REM stages, though in shorter and more flexible bursts. Some birds can reduce their sleep dramatically during migration, catching only brief episodes while in flight, then recovering later with longer rest. The presence of REM in birds suggests that this stage evolved before the divergence of birds and mammals, perhaps in a common ancestor more than 300 million years ago. If true, dreaming, or at least the neurological processes that underlie it, is an ancient trait, shared across vast evolutionary distances. Mammals inherited and expanded this architecture, developing rich cycles of non-REM and REM sleep that provide the foundation for memory, emotion, and physical repair. The complexity of mammalian brains, with their layers of cortex and networks of connections, demanded equally complex forms of rest. Sleep became not only a time of repair but also of integration, where information gathered in waking life was consolidated and woven into memory. In humans, with our exceptional capacity for learning, language, and imagination, sleep took on a particularly important role. Dreams, with their vivid narratives and emotional intensity, may represent the most elaborate expression of processes that began millions of years earlier in simpler creatures. Why, then, did sleep evolve and persist, despite the risks it creates. A sleeping animal is vulnerable, unable to forage, defend itself, or flee. Yet the fact that sleep has never been eliminated suggests that its benefits outweigh its costs. One explanation is energy conservation. By reducing activity during times when food is scarce or when predators are most active, animals preserve resources and avoid danger. Another explanation emphasizes neural repair and memory. Sleep provides unique opportunities for the brain to cleanse itself of waste, to reorganize connections, and to integrate experience. Still another explanation points to emotional regulation. By revisiting and reshaping emotional experiences during REM, animals maintain psychological balance. The true answer is likely a combination of all these factors, layered and reinforced across evolutionary time. The diversity of sleep strategies across species further illustrates how evolution has shaped this process. Dolphins and whales developed unihemispheric sleep, allowing them to rest one half of the brain at a time while continuing to swim and breathe. Birds evolved the same strategy for use during migration, balancing the need for vigilance with the need for rest. Bats evolved long hours of sleep, conserving energy while roosting in safe, sheltered environments. Elephants evolved short periods of rest, trading long sleep for more time to eat. Each strategy reflects the pressures of environment and lifestyle, but all share the same underlying requirement. Some form of sleep must occur. Even within humans, evolution has shaped sleep patterns. Our ancestors, living in groups, likely alternated their rest so that some remained lightly awake while others slept more deeply, increasing survival. Anthropological studies of traditional societies suggest that sleep was often segmented rather than continuous, with periods of wakefulness in the middle of the night, used for quiet reflection, socializing, or tending fires. Only with modern lighting and schedules did continuous, consolidated sleep become the norm. This flexibility shows that while the need for sleep is fixed, its expression can adapt to culture and environment. The evolution of sleep also raises deeper questions about consciousness. If REM sleep and dreaming are shared by mammals and birds, then the experience of internal worlds, vivid, imagined realities, may not be uniquely human. Other animals may dream in their own ways, their brains weaving images and experiences from their waking lives. Dogs may replay the chase of the day in their dreams. Birds may rehearse their songs. This possibility blurs the boundary between human experience and that of other creatures, reminding us that dreaming is not an isolated phenomenon but part of a continuum of life. Reflecting on the evolution of sleep, one sees both continuity and change. The core functions, restoration, memory, and balance appear in some form across species, while the strategies and patterns vary to fit the demands of survival. Sleep began as a simple rhythm of activity and rest, tied to light and darkness, and grew into the intricate cycles of modern humans, with their deep non-REM stages and vivid REM dreams. Its persistence across hundreds of millions of years testifies to its necessity. In the end, the story of sleep's evolution is the story of life itself, a tale of adaptation, resilience, and continuity. Sleep binds us not only to our own ancestors, but to every creature that has ever paused, drifted, and renewed itself in the quiet of the night. From jellyfish pulsing gently in the dark seas to humans lying beneath the stars, all share in this rhythm. Sleep is not only a human necessity but a universal inheritance, a gift carried through evolution, reminding us of our place within the great web of life. 17. Modern science and sleep studies. The scientific study of sleep is relatively young, yet in just over a century it has transformed our understanding of what happens during the quiet hours of the night. For much of human history, sleep was regarded as a kind of passive state, a blank interval between days in which the mind and body simply rested. Dreams were acknowledged as mysterious, but the mechanics of sleep itself remained hidden. It was only with the rise of modern science, first with electricity and brainwave measurement, later with advanced imaging and laboratory research, that the true complexity of sleep began to unfold. What once appeared as stillness revealed itself to be a rich and dynamic process, full of cycles, patterns, and hidden labor. Modern sleep studies have not only deepened knowledge but have also illuminated how profoundly sleep shapes health, memory, emotion, and even creativity. The first great breakthrough in sleep science came with the invention of the electroencephalogram, or EEG, in the early 20th century. This device allowed scientists to measure the brain's electrical activity through electrodes placed on the scalp. In 1929, Hans Berger, a German psychiatrist, recorded the first human EEG, discovering the rhythmic brain waves that mark different states of consciousness. When researchers began to apply EEG to sleeping subjects, they were astonished to find that sleep was not uniform, but divided into stages. Instead of being a gradual slide into unconsciousness, the brain followed a cycle of activity, alternating between slow waves and rapid bursts, with each stage associated with unique physiological patterns. This discovery overturned centuries of assumptions, showing that sleep is an active, structured process. The next great revelation came in the 1950s, when researchers at the University of Chicago, using EEG and careful observation, discovered rapid eye movement sleep. They noticed that during certain periods, the eyes of sleeping subjects darted back and forth beneath closed lids, and the brain displayed activity nearly as vivid as wakefulness. When awakened from this stage, subjects often reported intense dreams. This was the discovery of REM sleep, which has since become one of the central focuses of sleep research. The recognition that the brain alternates between REM and non-REM states transformed scientific understanding, revealing that sleep is not merely rest but a sequence of different types of activity, each with its own role in restoration. Sleep laboratories soon became central to this research. Volunteers would spend nights connected to EEG machines, their brain waves, heart rate, muscle tone, and eye movements recorded. These studies revealed the architecture of sleep, cycles of roughly 90 minutes repeating through the night, with deep, slow wave sleep dominating the early hours and longer REM episodes appearing later. Researchers correlated these stages with functions such as memory consolidation, hormone release, and emotional regulation, building a map of how sleep sustains life. The sleep lab also allowed the study of disorders such as insomnia, apnea, and narcolepsy, revealing their physiological roots and leading to treatments that improved countless lives. Advances in brain imaging further expanded understanding. Functional magnetic resonance imaging, fMRI, and positron emission tomography, PET, allowed scientists to watch which parts of the brain became active during different stages of sleep. These studies showed that while the prefrontal cortex, seat of logic and planning, rests during REM sleep, emotional centers such as the amygdala remain highly active. This explained the emotional vividness of dreams. Imaging also revealed the role of the hippocampus in replaying memories during non-REM sleep, transferring them to the cortex for long-term storage. With these tools, sleep could be studied not just as behavior but as a dynamic process within the living brain. Modern science has also uncovered the role of the glymphatic system, the brain's cleansing mechanism that becomes especially active during deep sleep. Researchers using fluorescent markers in animal models observed cerebrospinal fluid flowing through brain tissue, washing away metabolic waste such as beta amyloid. This finding, published in the 2010s, helped explain why sleep deprivation is linked to cognitive decline and neurodegenerative disease. For the first time, scientists could see how the brain physically maintains itself during sleep, reinforcing the idea that rest is not optional but essential for long-term health. Sleep studies have extended beyond the laboratory into daily life, thanks to wearable devices that track movement, heart rate, and even oxygen levels. While less precise than EEG, these devices allow large-scale studies of sleep patterns across populations. They have revealed how modern lifestyles, artificial light, irregular schedules, and constant stimulation affect sleep quality. Such data show that many people live in a state of chronic sleep deprivation, with consequences for health, productivity, and emotional well-being. These findings have prompted public health campaigns emphasizing the importance of sleep, much as earlier generations emphasized diet and exercise. One fascinating frontier of sleep research is the study of lucid dreaming. By training dreamers to signal their awareness with eye movements during REM sleep, scientists confirmed that lucidity is a measurable state. Brain imaging of lucid dreamers shows increased activity in the prefrontal cortex, suggesting that self-awareness can return even while dreaming. These studies have not only advanced understanding of consciousness but have also opened therapeutic possibilities, such as using lucid dreams to treat nightmares or to rehearse skills. The laboratory study of lucid dreaming exemplifies how modern science can explore even the most elusive aspects of sleep. Another growing area of research concerns the relationship between sleep and mental health. Sleep studies consistently show that disturbances in sleep are both symptoms and causes of conditions such as depression, anxiety, and PTSD. Insomnia often precedes episodes of depression, while nightmares intensify trauma symptoms. By studying these patterns, scientists have begun to develop therapies that target sleep directly, breaking cycles that perpetuate emotional suffering. Cognitive behavioral therapy for insomnia, for instance, has proven highly effective, demonstrating how knowledge from sleep studies can be translated into practical healing. The study of circadian rhythms has also advanced dramatically. Researchers have identified genes that regulate internal clocks, revealing molecular oscillators that keep time within cells. Nobel Prizes have been awarded for this work, recognizing its importance in biology. Sleep studies now explore how disruptions to circadian rhythms from shift work, jet lag, or artificial light affect health, linking them to metabolic disorders, cardiovascular disease, and cancer risk. Understanding these rhythms has led to chronotherapy, in which medical treatments are timed to the body's cycles for maximum effectiveness and minimal side effects. Sleep studies thus extend far beyond sleep itself, touching nearly every aspect of health. Despite all these advances, mysteries remain. Scientists still debate the ultimate purpose of dreams, the precise balance of functions across different stages of sleep, and the reasons why sleep needs vary among individuals. They continue to explore why some people thrive on less sleep than others, why certain disorders develop, and how sleep evolved across species. Each discovery reveals more about the richness of sleep, but also more questions, ensuring that the study of sleep remains an ongoing journey. Reflecting on modern science and sleep studies, one is struck by the transformation of perspective. What once seemed simple has been revealed as profoundly complex. Sleep is not idleness but a carefully orchestrated process, balancing cycles of rest and activity, cleansing and integration, emotion and memory. The laboratory, with its wires, sensors, and imaging machines, has given us a glimpse into this hidden world. Yet beyond the data and graphs, sleep remains a deeply human experience, a nightly journey through silence, dreams, and renewal. Modern science does not diminish the mystery of sleep, it deepens it. Each discovery shows that the night is alive with processes more intricate than we ever imagined. To study sleep is to peer into one of life's oldest and most essential rhythms, one that links us to every creature that has ever rested. Each night, as we close our eyes, we join in this ancient cycle, carrying forward a tradition that science continues to explore but never fully explain. 18. The quiet gift of dreams. Dreams arrive each night without invitation, carried gently on the currents of sleep. They come silently, woven into the fabric of REM cycles, painting the inner landscape with images, emotions, and stories. Though often forgotten by morning, dreams represent one of the mind's most delicate gifts, the capacity to create entire worlds while the body lies still. They are quiet in the sense that they require no effort, no conscious summoning, and yet they shape our lives in ways both subtle and profound. To consider dreams as a gift is to appreciate them not merely as curiosities or fragments of imagination, but as part of the hidden labor of sleep, nurturing memory, healing emotions, and enriching the inner life. The gift of dreams begins with their ability to transform memory into experience. Throughout the day, the mind is filled with impressions, faces glimpsed, words spoken, tasks completed, emotions stirred. Many of these impressions are stored, but in dreams they are not merely replayed. Instead, they are reshaped, combined, and reimagined into scenarios that defy the order of waking life. A person might find themselves speaking with someone long gone, or walking through places never visited, or solving problems that seemed insurmountable by day. This reassembly of memory into narrative reflects the brain's effort to weave coherence from fragments, to test connections, and to integrate new experiences into the larger web of knowledge. Without this nightly gift, memory would remain brittle, disconnected, and incomplete. Dreams also serve as gifts to the heart, helping emotions soften and find their place. The events of daily life often leave feelings unresolved, fears unspoken, joys fleeting, sorrows unhealed. During REM sleep, the amygdala, the brain's emotional center, remains highly active, while the stress chemistry of waking life subsides. In this state, emotional experiences can be revisited without the full force of fear or tension. A dream may replay a troubling event, but within the dream, the mind has the chance to approach it from new angles, to alter its course, or simply to witness it with a gentler perspective. In this way, dreams act as overnight therapy, allowing emotions to be processed in safety. The gift they offer is balance, the quiet easing of burdens that might otherwise weigh heavily upon the waking mind. There is also a gift of creativity within dreams. The dream state allows connections that would rarely emerge in waking life. Logic is softened, boundaries blurred, and imagination set free. Artists, scientists, and thinkers across history have reported receiving inspiration in dreams. Melodies, inventions, solutions to problems. Whether or not one believes these accounts, it is clear that dreams open pathways to creativity by combining ideas in novel ways. Even dreams that seem nonsensical may plant seeds of thought, influencing later insights. The gift here is not the dream itself, but the freedom of the mind to explore without constraint, to wander across the landscapes of possibility. Yet not all dreams are pleasant. Nightmares, too, are part of the gift, though their value is sometimes hidden. They often reflect fears, anxieties, or unresolved conflicts, presenting them in stark imagery. While distressing, nightmares serve a purpose. They bring hidden concerns to awareness, force the mind to confront what it would rather avoid. The ancient theory of dreams as rehearsals for danger finds support here. In simulating fear, the mind sharpens its readiness. Though painful, nightmares remind us that even discomfort can be a form of care, guiding us toward resolution or resilience. Their gift lies in their honesty, in their unflinching presentation of what troubles the soul. Dreams also connect us to one another in ways that transcend waking life. Many people dream of loved ones, living or departed, and in those encounters feel comfort, joy, or closure. A dream of a lost parent or friend may bring a sense of presence more vivid than memory alone, softening grief or rekindling love. Though these experiences cannot be measured or explained in full, they reveal how dreams serve not only individual memory but relational bonds. They allow the mind to preserve connection, to hold others close, even when distance or death separates us. This gift of communion is one of the most tender aspects of dreaming, offering solace in the quiet hours of night. Across cultures, dreams have been regarded as sacred, another kind of gift, not from the brain but from the cosmos, the gods, or the ancestors. Ancient people read dreams as messages, guidance, or warnings, and though modern science interprets them differently, the reverence remains understandable. Dreams often feel as if they come from beyond us, their imagery unexpected, their emotions profound. Whether seen as divine or neurological, the gift is the same. Dreams remind us that our minds contain more than we control, that we are participants in mysteries greater than ourselves. Children, in particular, reveal the natural abundance of this gift. Their sleep is rich in REM, and their dreams are often colorful and fantastical. Many children recount adventures with imaginary creatures, flights through impossible worlds, or conversations with figures of wonder. These dreams reflect both the rapid growth of their brains and the openness of their imaginations. As adults, dreams may grow subtler, shaped more by memory than by pure fantasy, but they remain gifts nonetheless, less visible perhaps, yet no less essential. The shift reminds us that dreaming, like life itself, evolves across time, serving different purposes at different stages. The quiet gift of dreams lies also in their transience. Most dreams vanish upon waking, leaving behind only fragments or impressions. This forgetfulness might seem like a flaw, but it may in fact be part of their value. Dreams are not always meant to be remembered in detail. Their work is often done invisibly, leaving the mind subtly altered. Just as a seed grows beneath the soil unseen, so dreams may change us without our knowing. The morning may bring a lighter heart, a softened sorrow, or a spark of creativity. Even if the dream that shaped it is forgotten, their gift lies not only in what they show, but in what they quietly accomplish. To dream is to experience both the familiar and the impossible, to live through moments that blur the line between memory and imagination. It is to receive night after night a gift from the mind itself, one that restores, inspires, and connects. Whether joyful or troubling, vivid or forgotten, dreams are part of the deep renewal that sleep offers. They remind us that even in unconsciousness, life continues in rich and mysterious ways. The gift is not always in clarity or meaning, but in the simple fact that the mind, even at rest, creates. When one reflects on the quiet gift of dreams, it becomes clear that they are not mere illusions. They are acts of the mind, woven into the essential rhythm of life. They allow us to carry forward memories without pain, to imagine beyond limits, to connect across absence, and to awaken renewed. Each dream, whether remembered or not, is part of this hidden gift, bestowed freely each night. In their quiet way, dreams are reminders of the depth of human existence, the vastness of the inner world, and the unceasing creativity of the sleeping mind. 19. Preparing the mind for rest. As evening approaches and the body begins to sense the fading of light, the mind, too, enters a transition. The shift from wakefulness into sleep is not instantaneous but gradual, guided by rhythms that prepare us for the night's deep restoration. Preparing the mind for rest is both a biological process and a gentle art, involving changes in chemistry, emotion, and thought that allow the day to settle quietly into night. This preparation is ancient, woven into the very fabric of human life, yet it is also delicate, easily disrupted by the pace and brightness of the modern world. To reflect on how the mind prepares for rest is to recognize the subtle ways in which sleep is invited rather than forced, allowed rather than demanded. The process begins with the circadian rhythm, the body's internal clock that responds to the setting sunday. As darkness spreads, the pineal gland increases its secretion of melatonin, the hormone that signals night has arrived. Melatonin gently lowers alertness, slows the firing of neurons, and encourages drowsiness. At the same time, body temperature begins to fall, creating a sense of calm that supports sleep onset. These biological cues act like an orchestra, slowly guiding the mind towards stillness. When aligned with natural patterns of light and darkness, they make the transition effortless. When disrupted by artificial light or irregular schedules, however, the mind struggles to prepare, clinging to wakefulness even when the body is weary. Yet, biology is only part of the story. The thoughts and emotions carried into the night play an equally important role. Throughout the day, the mind gathers concerns, plans, and unresolved feelings. If these remain active, they can interfere with the descent into sleep. The mind resists letting go, replaying conversations, or imagining future tasks. This is why practices that encourage winding down are so valuable. Quiet reflection, reading, or gentle rituals signal to the mind that the day is ending. By creating boundaries between the activity of day and the rest of night, they ease the shift into slumber. In traditional societies, such transitions were often marked by firelight, shared stories, or prayer, each serving as a bridge between worlds. The environment also plays a profound role in preparing the mind for rest. Darkness is the most powerful cue, reminding the brain of its natural rhythms. Softness, quiet, and coolness all contribute to the sense of safety needed for sleep. The mind, ever watchful, does not release itself into unconsciousness unless it feels secure. A quiet room, a consistent space, a familiar routine, all reassure the nervous system that it can let go. This is why travelers often find it difficult to sleep in unfamiliar places. The mind remains alert, sensing the possibility of danger. Over time, however, familiar cues become associated with rest, and the mind learns to relax more quickly in their presence. Preparing for rest also involves the gradual withdrawal of attention from the external world. In waking life, attention is directed outward, scanning for information, responding to signals, and solving problems. As sleep approaches, attention turns inward. The senses grow less responsive, the eyelids close, and the chatter of thought begins to soften. This inward turn is not abrupt but gradual, a gentle loosening of focus. Daydreams and drifting thoughts often appear in this twilight state, a prelude to dreams. The mind begins to rehearse its nightly shift, leaving behind the strict logic of waking life and opening to the fluid imagery of sleep. Emotionally, the preparation for rest is also a process of release. The stresses of the day, if carried too tightly, can prevent the mind from quieting. The body may lie still, but the heart remains restless. This is why many traditions emphasize evening practices of gratitude, reflection, or prayer. By acknowledging the day, accepting its challenges and joys, and letting them rest until tomorrow, the mind unburdens itself. Such practices are not merely spiritual but psychological, creating closure that allows sleep to come more easily. Even something as simple as writing down thoughts or tasks can free the mind from holding them through the night. Modern life, however, often pulls against these natural preparations. Artificial light delays, melatonin release, screens capture attention, and constant stimulation prevents the mind from unwinding. The result is a state of hyperarousal in which the nervous system remains ready for action, even as the body longs for rest. To prepare the mind in such circumstances requires conscious effort. Dimming lights, setting aside devices, and embracing quiet rituals that counterbalance the demands of the day. In doing so, one reclaims the natural rhythm that the body still remembers, allowing sleep to return as it always has, in silence and darkness. The transition into rest can also be understood as a shift from control to surrender. During the day, the mind exerts effort, directing attention, making choices, solving problems. Sleep, by contrast, requires letting go. One cannot will oneself to sleep. One can only create conditions in which it arises naturally. This surrender is often the hardest part, especially for those accustomed to constant activity. Yet it is in this letting go that rest becomes possible. The mind, released from its grip, drifts into the cycles that sustain life. The preparation, then, is not about forcing, but about easing, not about command, but about trust. Children reveal this truth clearly. When their days are full of play, their nights often begin with stories, songs, or gentle routines that ease the transition. These rituals provide not only comfort but also a signal to the mind that sleep is near. Adults, though often neglectful of such rituals, benefit from them just as much. The act of slowing down, of marking the boundary between day and night, supports the ancient rhythm that lives within every person. To prepare for rest is, in a sense, to return to simplicity, to acknowledge that sleep cannot be rushed but only invited. The preparation of the mind for rest is also a preparation for dreams. By setting aside the day, creating calm, and opening to stillness, one allows the dream world to unfold more freely. The images that arise in sleep are shaped in part by the state of mind carried into it. A restless mind may bring restless dreams. A calm mind, gentler ones. In this way, preparing for rest is not only about ensuring deep sleep, but also about shaping the quality of inner experience. Nightly rituals, environments, and emotional states all contribute to the landscape of dreams, influencing the journey the mind will take in the hours to come. Ultimately, preparing the mind for rest is both natural and intentional. The body is equipped with rhythms and signals that guide the process, but the choices of daily life can support or hinder it. By aligning with natural rhythms, by creating environments of safety and calm, and by practicing gentle release, the mind can move gracefully into sleep. This preparation is not a task, but a gift, a way of honoring the night and allowing it to perform its quiet work. To prepare for rest is to acknowledge the day, to let it close, and to trust that tomorrow will come in its own time. It is to enter willingly into the rhythm of life, where activity yields to stillness, and stillness yields again to activity. Each night, this preparation opens the way to restoration, to dreaming, and to renewal. The mind, once readied, drifts into the deep waters of sleep, carrying the self gently into the hidden cycles that sustain life. 20. Gentle conclusion. Returning to the night. As the long journey through the science of sleep and dreams draws to a close, it is fitting to return to the quiet simplicity from which it began. Sleep, though explained through waves, cycles, and chemistry, is more than the sum of its parts. It is a nightly return to balance, a surrender to rhythms older than memory, a gentle reminder that rest is woven into the very fabric of life. To conclude is not to end the story of sleep, for its mystery continues each night, but to gather its lessons and hold them softly, as one might cradle the fading light of evening. Throughout this exploration, we have seen that sleep is not mere absence, but presence, a presence of activity hidden beneath stillness. In the depth of non-REM, the body repairs tissues, strengthens immunity, and clears away the day's cellular clutter. In REM, the mind rehearses emotions, softens memory, and creates dreams as vivid as waking life. In circadian rhythms, the body aligns with the turning of the earth, keeping time with sun and shadow. In every stage and cycle, sleep performs a work no waking effort can replace. To return to the night is to trust this hidden labor, to allow it to unfold without interference, knowing it sustains life itself. Dreams, too, have accompanied this journey, appearing not as curiosities but as companions. They reveal the mind's creativity, its ability to weave stories from fragments of memory and emotion. They soften grief, rekindle joy, and inspire new thoughts. Sometimes they disturb, reminding us of fears unspoken. Sometimes they comfort, bringing back faces we thought lost. Whether forgotten or remembered, dreams perform their quiet work, shaping the self in ways beyond our awareness. They are gifts, freely given, reminding us that even in unconsciousness, the mind remains alive, weaving meaning in silence. The disorders of sleep, gently considered, remind us of its fragility. Insomnia, apnea, night terrors, and narcolepsy show what happens when rhythms falter. Yet even in these disruptions, the body's longing for rest is evident. Sleep is not optional. It is demanded by life itself. When it is hindered, health and mood decline. When it is restored, renewal returns. The persistence of sleep through every species and across every age speaks to its necessity. From dolphins who rest one hemisphere at a time, to elephants who sleep only a few hours, to humans who dream in vivid cycles, all life is bound by this rhythm. The science of sleep, explored in laboratories with wires and glowing screens, has illuminated much. The architecture of stages, the cleansing of the glymphatic system, the replay of memories, the regulation of emotion. Yet even with these discoveries, sleep retains its mystery. No chart of brainwaves can capture the feeling of drifting into slumber, of being carried gently by cycles beyond our control. No scan can measure the comfort of a dream that restores a grieving heart. Science explains much, but it cannot diminish the wonder of the night. Instead, it deepens it, showing that beneath the quiet lies a world as intricate as waking life, and perhaps even more essential. Preparing for sleep, as we have seen, is both natural and intentional. The body follows its rhythms, guided by light and darkness, yet the mind benefits from rituals that ease its way. Quiet moments, soft environments, gratitude, or reflection all help create the space where sleep can come without struggle. To rest well is not to force slumber but to invite it, to honor the transition between day and night. In this, sleep is a teacher, reminding us of the art of letting go, of yielding to processes we cannot command, but can only trust. Emotion and sleep, too, remain inseparable. Each night, feelings are processed, softened, and integrated into memory. Without sleep, emotions grow sharp and unsteady. With sleep, they regain balance. This nightly therapy sustains mental health as surely as it sustains physical health. It reminds us that rest is not only for the body but for the heart, offering peace that cannot be found in waking effort. Sleep restores clarity not by erasing emotions but by reshaping them until they can be carried with steadiness. Across the animal kingdom, sleep reveals its universality. Birds resting with one eye open, whales drifting with half a brain awake, cats twitching in dream. Each shows the necessity of rest, adapted to the needs of survival. Evolution has preserved sleep through countless challenges, for no creature can thrive without it. This shared rhythm connects all life, linking humans not only to ancestors but to every living being that has ever paused in the night. To sleep is to participate in a continuity older than species, older than memory, a rhythm as old as Earth's turning. And so, as this exploration concludes, we return to the night not as scientists or observers, but as participants. Each evening, we close our eyes and surrender to what generations before us have done, what every creature continues to do. We sleep. The cycles unfold without our effort, carrying us through depths and dreams, cleansing and restoring, softening and preparing. When morning comes, we rise renewed, carrying forward the quiet work of the night. Sleep, then, is not simply an end to the day but a beginning of restoration. It is both universal and intimate, both measurable and mysterious. It is the quiet ground on which waking life stands, the hidden labor that makes thought, emotion, and action possible. To understand it is to glimpse the depth of life's wisdom, the way nature has provided balance within every cycle. To honor it is to recognize that rest is not idleness but life itself continuing in another form. As the world outside grows dark and still, so too may the mind grow calm. The day's tasks can be set aside, its burdens laid down. In their place comes the gentle rhythm of breath, the slow drift into cycles that cleanse and renew. Dreams will come, unbidden yet welcome, carrying fragments of memory and imagination. The body will heal, the mind will soften, the heart will restore, and when dawn returns, the self will be ready once more for life. In this way, each night is both an ending and a return. It is the closing of the day and the opening of the hidden world of sleep. To return to the night is to trust in the wisdom of the body, to yield to rhythms older than time, and to receive the gift of renewal. Quietly, without effort, sleep will come, carrying us through its cycles and returning us to morning refreshed. This is the gentle conclusion of all our days, not silence, but the music of the night, playing softly, endlessly, sustaining life with every note.